Okay, so first question is a function question. All right. So it says that I hope this is not too small. Okay, I think this should be fine. All right. This is the function. Now, one thing I noticed, right, some of you are probably don't know whether you are clear or not clear, or maybe you are just blur. Okay. That there is an alpha in the question and there's an A in the question. Okay, so I mark at least one or two friends. The alpha is A, the A is alpha. I'll take note. This question, it will not work. Are we all clear? Alpha is alpha, A is A. Are we all clear? Can? All right, so don't confuse like this. Just read the question carefully. Come on. All right. Part one is supposed to be easy. Okay. It says that state and it's only 1 mark. So if you look at 1 mark and it says state, you probably like, just see and get the answer off the screen maybe. Speaking of which, let me load my GC. Oh yeah, my GC is there. Okay, that's cool. All right. So for which the F inverse exists. So the first thing, concept, you must check with yourself. Do you know what makes F inverse exist? Okay. Do you know what is the condition for F inverse to exist? That's important to know yourself. Okay, so F inverse exists if it's 1 to 1. All right, then the next question is how do you check 1 to 1? Well, normally we sketch, correct? So we sketch, we draw the horizontal line test, we say it's 1 to 1. Now this one is not impossible to sketch because despite us not knowing alpha, you still can roughly pretend alpha to be 1 or something, just get the shape out, right? So not too bad, you can actually do that. Have a quick sketch to see that where you're going to chop it off so that it become 1 to 1. All right. Now that said, there are questions whereby you can't really sketch. Okay, there are. Those of you in my class, I think a couple of months ago we did one particular revision, and that was I think it was a piecewise function or something. So you can't sketch. Okay, then you also need to confirm that it is 1 to 1. All right, then that one is a different beast altogether. Okay, so my point is concept. All right, I want to talk about concept that that's required for you to solve this question. All right, and then after that the actual doing. So how do we do this? Well, Mr. Mr. I can sketch this. Okay, so you can go to the GC, punch it in. I guess you see something that looks symmetrical. Okay, not hard to understand why symmetrical, because it's a square. All right, it will be symmetrical. So you just have to get to the middle point and then try to chop it into half, and then that becomes 1 to 1. Are we all clear? Now the only problem is because alpha you don't know, so you have to assume alpha to be 1 or 2 or whatever favorite number you have. But then you cannot trust your GC for that point anymore, right? Okay, so another option that you have is actually for it to be 1 to 1 means it cannot have a turning point. Quite easy to understand, right? Okay, cool. So I will show you the working, the one with a little bit more working one, and that is you probably go and find the turning point. Okay, so you go and differentiate, which is, to be honest, not difficult to differentiate. So you can't complain that this is difficult to differentiate. All right, let me just quickly do it. Right, so if you differentiate it and you equate to 0, you're trying to find the turning point. Okay, and of course, this cannot be 0, 2 cannot be 0. Okay, basically you know what I'm talking about, right? 2x plus alpha must be 0, and then alpha must be negative x over 2, alpha over 2. Okay, here we go. All right, what it means is that I don't know how the curve look like. Okay, I actually don't care also, but I only know that at this point, okay, when x is this point, well, there is a turning point. Okay, that's where the gradient is 0 and stuff like that. So you already assume that you already know that it must be some kind of a symmetrical one and so on. So there you go. Okay, so that's the what you will see on the equivalent if you punch into your GC, and then that's what you're trying to figure out, the symmetry. Okay, and of course in this case means well, k must be negative alpha over 2. All right, because that's when you want to chop the curve into 2. All right, and when you chop the curve into 2, it becomes 1 to 1. All right, I mean, in case you're wondering, that's how the curve will look like. Okay, all right, so whatever alpha value we put in, you'll look a bit like this. Okay, anyway, so that's just 1 mark, pretty easy. Some people give me the answer like, just like that, no working. It's fine. All right, no working is fine because it's just 1 mark or answer mark and that's it. Okay, next one. Using the value found in part 1, right, the k part, find the F inverse. Now, this is not so well done, okay, and for a couple of reasons. I do want to highlight, okay. So 3 marks, not a lot of people get all full, okay, but generally it's not hard again, right? So find F inverse, everybody knows, right? Usually the first step is we just let y, okay. So we let y. The only unsettling thing for some people is because of the alpha. All right, what happened is that when they have an alpha dangling around, they just feel uneasy. But generally, you don't care. You just have to try to make X a subject, right? So you law on both sides. Pretty obvious, you have to law on both sides. Okay, and then you got to make X a subject. Therefore, you got to square root both sides. Now, this is the part that I start to minus marks for some people. All right, believe it or not, at this level, still got people forget to put a plus minus. All right, this is not acceptable. Okay, yeah, at your level, it's not acceptable. Okay, secondary school kids, yeah, maybe, you know, they forgot, right? They're not sure when to have plus minus. For you guys, no way. All right, you have to have the plus minus, otherwise you're gonna get marks. So when you make the X the subject, or rather 2x the subject, you're going to get minus alpha plus minus square root of this. And then, of course, well, full-fledged x the subject is going to look a bit like this. Now, the truth is, you suddenly have two sets of answer. Okay? And again, there are people who actually gave me, because they don't know what to reject, you see. So when you don't know what to reject, then you don't reject, you just keep both. Sorry, also wrong. Okay? You cannot keep both. You have to be brave and be clear about, hey, I need to reject one of them. Common sense, you cannot have two inverse function for one to function. You get what I mean? Like function one is to go, the inverse to come back, right? So you cannot have one to go and then two to come back, what? Get the point? So you cannot have two, you must have one. So you got to decide for yourself, okay, now what? Which one? Okay, which one is the one? So this is when your GC may come in a bit handy. Okay, now this kind of plus minus problem only occurs when your function is symmetrical. All right, when your function is symmetrical, you got plus side, you got minus side. Okay, what I mean, probably a bit easier for me to just punch it in and show you. Okay, so if you bother to do exactly that just now, okay, 2x plus. I'm just gonna assume alpha is 1. Just pretend. Okay, nobody says so, but I pretend. So you look at the graph. Like I say, it's symmetrical, right? So you're gonna look a bit like this. Let me just blow it up a bit. Okay, there you go. All right, cool. Okay, so with that in mind. Then you understand that, okay, you know what, the original function is a bit like this, and I figure out that this was the negative alpha over 2, and pay close attention to the domain. The domain is not there for fun, okay? It's literally there to tell you, hey guys, you know what, I'm actually only taking this side. Okay, and that is why this side is the one-to-one. And the inverse that you're trying to find is the inverse of this joker. Understand? The inverse of this orange side, not the whole thing, because the whole thing doesn't have an inverse, because inverse doesn't exist for the whole thing. In other words, okay, if you are dealing with the left side of the curve, I mean, come on, symmetrical means you got left or right, right? So it's not hard to understand that left side corresponds to the negative root, right side corresponds to the positive root. In other words, okay, the one that you should reject is this one. Okay, now you don't just reject like that. I think it's a good manners for you to just at least tell people why you reject them, right? So you should write something like this, okay? Since the domain of f is equal to minus infinity to minus alpha over 2, okay? I mean, come on, this is the domain, yeah? Okay, all the way from the left to the minus alpha over 2. Then you just, therefore, f inverse x is equal to the negative version, all right? The one with the negative root, not the one with the positive root. So however you want to write this is entirely up to you. You want to multiply in the half is up to you. You want to take out the negative, up to you. But the whole idea is you must choose the right one. There you go. Now, that's not the end. You got 2 marks out of 3. Okay, all right? You got 2 marks out of 3, yeah? All right, so one last mark, and that is the rule that says every time, all right, every time you give a function, whether is it inverse, composite, or whatever not, you must give the domain. So the domain of the f inverse is the range of the f, and it's not hard to tell what is this range of the f is. Okay, I mean, you can go and sort it out. Substitute in the x value to find the y value. Okay, I mean, let me just show you quickly, in case you blur, don't know what I'm talking about. Okay, again, I'm not too sure how blur you are, but then you just have to let me know in case you're super blur. Okay, put it in. All right, you're going to get, not put in here, sorry, put into the x, okay? So you're going to get 0 power, right, which is 1, okay? All right, so there you go. That point turns out to be quite useful later. So let me just mark it here. All right, so the range is from 1 to infinity, so the domain is from, well, 1 to infinity. Okay, so let me tell you the allocation of the marks here. The plus minus, 1 mark. Choosing the right version, 1 mark. And the domain, 1 more mark. Okay, sorry, Yang, I see your hand. You want to ask something. What if I directly wrote this and the reason but never write the positive, negative sign? Okay, you got right reason, that'll be okay. As long as there is a reason for you to reject this joker, you'll be fine. All right, because generally speaking, when you talk about mathematically correct, whenever you square both sides, you always have the plus minus. But it's just that not all the time the plus minus makes sense. Agree, right? And therefore, sometimes when it doesn't make sense, we just straight away ignore. All right, and we don't even write. Okay, so in this case, if you happen to know, because like that, so the plus, it doesn't make sense, right? Okay, then as long as you give some reason like why you reject this, okay, I think it's fair. Okay, so the presentation doesn't have to be exactly like what I wrote, okay, you can have your own style and all, but the whole idea is the concept must be very clear. Okay, all right. Thank you, Yang Ying, for asking that. Sorry, I mean, I can't hear you, so in that sense, you have to type out your question, which is a bit slow, All right, that said, that's part 2. Are we okay? Any questions? If not, let's move on now because we have a lot of questions to cover. Okay, next one. We're talking about let alpha be 1 now. Okay, I'm going to use another color. Okay, so that yeah, we can be quite sure about the different parts to it. Okay, all right. So alpha is 1 now. Sketch on the same diagram F inverse and this one. Now this is interesting. Okay, this is interesting. This is the one that I get a little bit disappointed when I don't give people the 1 mark. Okay, so F inverse, meaning sketch this joker Okay, and I don't know how many of you did how you did it but you probably use GC. Okay, and I won't be surprised. Neither is it too difficult because alpha is equal to 1 now, right? Let me see. Okay, alpha is equal to 1, right? So your F inverse literally look like this. Okay, sorry, this should be X. Oh dear. Sorry, my bad. Okay, so copy down. So it should be X there. All right, ln X, sorry, my bad. Okay, and X more than 1. So this is literally how your F inverse should look. Okay, and of course, you should just go to your GC, punch it in, and then you get the graph. Okay, so it's not difficult to get it from the GC. I'm not going to show you how I punch inside the GC. You probably will get quite nice looking thing which is over here. This will be 1, and this will be at -half because the alpha, and it should look a bit like this. It should look a bit like this. Okay, so just for context, the original that I showed you earlier on was here. This orange one. Can you see that? Okay, all right. So the original was there. So I assume alpha to be 1 just now when I use my GC, right? Agree? Okay. So now alpha is 1. So the green color part is supposed to be a reflection along the line y equal to x for the blue color one. Are we all good? All right. And of course, the points that we had earlier on is actually useful because you see the point used to be at -half 1. And when you do the reflection, it becomes 1 -half, which is how I get this point relatively painlessly. Okay, so if you know how things all work together, it's not as bad. Or rather, it's not like hunting in your GC trying to figure out where the point is. It's actually supposed to be quite fast and easy. Okay, this is 1 mark, by the way. Okay, this diagram. Speaking about drawing diagram, at your level, again, please, okay, do not draw this. What's the difference? Only the circle, right? Only this little nonsense right here, right? This thing here, okay? Now this is important, and please don't do this. All right, you are not Sec 3 anymore. Get the point? Okay. So across a dot won't work. Please be confident whether you want to include this point or don't include this point. Be very, very confident about it. Okay, because when you're not confident, teacher's not going to give you the mark. That's all. Simple enough. Okay, because you're not sure what. All right, so take note, this is 1 mark, this is one tail like that. Of course, please label. I think I don't need to nag on that, right? Okay. Now, the painful thing that I saw is how some students didn't get the other 1 mark. That's painful. You know why painful? Okay, what they want me to draw? Well, this. You should know that this is, after all, just y equal to x. Okay, don't please don't go and do this. Okay, don't go and, oh, Mr. I sub in this joker into my F inverse, which I can't even see here. And then I work it out. It looks like a mess. Yep. If you clear up the mess, it's just X. Okay. So I don't think you need to go and clear up the mess. And so far, I didn't see anyone did that, so which is good. All right. So it is a kind of the important thing that you know immediately. This is just Y equal X. Okay. And that's it. It's really just that line called Y equal X. Okay. Now, if you just draw that line like this, you won't get a 1 mark either. Okay, you won't get a 1 mark. So you need to understand this. Okay. Now, sorry, it's F inverse F. Okay. The domain of your F inverse F is the domain of F. Okay. Now that is important to understand. All right. That is something you have to somehow understand, or you memorize. This is called composite function. All right. The domain is always the domain of the first function. So the domain of F, usually you don't have to find, because domain of F is given one, right? And it's right here. See this fella? Okay. X less than K, which is minus, okay, minus infinity to minus half now. Okay, cool. All right, because we know that K is alpha over 2 negative, and alpha is now 1. So, okay, get the point? So what you're supposed to do or draw is a line, yes, but please draw from here onwards. Okay, it's a line. That is true. It's just the Y equal X line, really. But please, it's a half line. Get the point? You don't draw it all the way, all right? Cuts through origin, whatever. No, nonsense, all wrong already. Okay, so marks allocation quite easy, 1 mark, but make sure you know the coordinates to be correct. Okay, meaning to say, you either do the ... in exams, okay? If not, then you label the coordinates. All right, so either or. If you don't, how am I going to know that you are referring to this being 1? Okay, maybe I got some parallax error and I thought you mean 2. Okay, so to be really clear in exams, you do want to do the ... thing. All right, if you think that the ... thing becomes very messy for a graph because maybe you got OCD, then you label then. Okay, label the point next to it. Get the point? So it's important, all right. Okay, we have someone coming in. I just let anyone in already, Okay, so that's 2 marks for part 3. Any questions at this moment? I don't think so. Come on, I got to move on faster. One question cannot take so long. Okay, next one. Where are we now? Part no, I can't see my question. Part 4. Okay, all right. Now this one, okay, I tell you what. I probably need to see the question, right? Better than this scroll up and down. Let me make everyone see sick. Okay, here we go. All right. So I'm just gonna paste it here. Okay, so the function g is defined by this. Okay, on a separate diagram, draw this indicate clearly. Okay, 2 marks. Now, guys, this is supposed to be really easy. Okay, after all, this is a line that's being mod and then bring up and stuff like that. It's not hard. All right, understand that a is a positive number that will be useful. Okay, so I honestly think that the only reason people get this wrong was because they didn't give the details. Okay, so let me just quickly run through because this is not difficult stuff. All right, so the first thing, well, I'm just going to go through how I did it. Okay, so maybe you did it for like you used very long to do it, right? So you want to learn how to do it fast. Okay, so in my mind, I'm sketching this. Okay, so I'm actually looking at, okay, I'm going to draw this. Then I'm going to mod it. Okay, and I know this at minus a, this at a. All right, and this is this. Correct? I'm going to move up by a, so definitely this is going to be 2a. This is going to be right here. And this is my graph. Done. Okay? Can? All right, you're supposed to be able to do this. Come on, which part of it you never learned before? I don't think so. Come on, you learn all this in secondary school. Okay? So it's just moving up, down, flip up, flip down. That's all. Okay? It shouldn't take more than what? 1 minute for 2 marks. Okay? So again, I did see some people when they drew their graph, they very excited draw everything. Sorry, wrong. Okay? Why? Because question says only the negative side. So you minus 1 mark because of that. Okay, and the question deliberately says that you have to indicate all the intercept or whatever nonsense. Then this one is obviously worth 1 mark. Okay, and the other one that's worth 1 mark is this ... thing. Okay, identify this vertex. Okay, you don't just expect people to guess what you're trying to mean. Get the point? All right, so 1 mark here, 1 mark there. Okay, so that's 2 marks. Rather easy stuff. Okay, so let's move on. The part 5 is the not so easy one, and this is the pain that many J1 students have when they first learn functions, right? Functions is actually very easy, but there's only one part that is really confusing, and this is the part, okay? And that's to find the exact range of a composite function when you can't draw it sometimes, okay? But first of all, let's talk about the show first, right? You're supposed to show that the GF inverse exists. Okay, so so far I see everybody's work, it was correct lah. So it says that GF inverse exists, all right, if the range of F inverse is a subset or equal to the domain of G. Okay, and all you need to do is to check this. That's all. Okay, so the range of F inverse is the domain of F, and the domain of F, I believe I was talking about it just now, right? The domain of F is this one. Okay, minus infinity to minus half. But I got one very strange thing that I observe. You see, when we write a range in set notation like this is supposed to be lower limit, upper limit, right? Huh? I guess all of us learning like that, right? So when I saw a student who wrote it like this, I was like, I don't know where he learned this from. So I thought it was one-off thing until I saw a second student who wrote like this. And then I saw a third one who wrote like this. I was like, hey, something is wrong. You know, they're not same school. Okay, so I don't know what went wrong. Okay, or maybe the teacher in school never emphasized enough to tell you that, hey, this must be the lower number, this must be the upper number. I don't know. Okay, so take note, nowadays you're learning your normal CDF and all, right? You always put lower limit, upper limit. Get the point? You want to think like that. Okay, so don't put it upside down. It's very confusing, you know. All right, and when I was marking, I was like, what the heck is it trying to say, you know, or am I missing something? And you know how some students write their thing, sometimes the negative is like, don't know whether is it negative or decimal, you know, that kind of thing. All right, anyways, it was a very curious thing that I saw, and I thought, you know, in case you also wrote it upside down, okay, and that will be something quite puzzling for me, it's not serious, but puzzling. All right, anyways, domain of G is right here. Okay, so there you go. Is it a subset? Pretty obvious it's a subset, right? Okay, so we say that, well, since since the range of F inverse is indeed a subset of the domain of G, right? Then therefore this exists. By the way, there's only one mark, so all you need to show is this logic thinking. Okay, the logic thinking, this must be correctly identified. I correctly identified, and then the correct, all these are 1 mark all together, only 1 mark. Okay, so it's not so expensive kind of thing, but it's very easy, so you cannot complain. Now the other 1 mark, which is this one, cause a lot of pain. Okay, why? Because some people just never get it. Okay, so let's try to understand. The idea is, you want to find the range of the GF inverse. Okay, so the idea is that function behave like machines, right? Okay, so the first function is the F inverse. All right, so the first function is the F inverse. Now, what you found out was that the range of the F inverse, which is here, whatever comes out of the F inverse, all right, is now a subset of a bigger one, right? So the bigger one is the second one, right? The second one is G. Okay. All right, so what you want to figure out is, hey, you know what, these green people, all right, if it goes inside, okay, what are they going to be like here? That is your job. That's all. Okay, so if you understand what you're trying to do, that is exactly what you're trying to do. Okay, so this one is the range of your F inverse, which is minus infinity to minus half. This one, whatever that comes out of it and put inside the second function, right? Okay, maybe I should draw arrow, otherwise you don't know where is it heading, right? Okay, so what you want to know is from minus infinity to minus half, and I put inside G, what will come out of it? Get it? That is the concept, that's all. Okay, that's all. So how do you find this out? Well, G is right here. By the way, I didn't label. That's a bad habit. I think I should. Y equals to Gx. Okay, you should label, otherwise you get a bit confusing. So what you want to find out is, if I put in the numbers from minus infinity to minus half, I'm supposed to try to figure out where is what will come out of it. So minus infinity is well, all the way down. Minus half, now here comes a problem. A serious problem. You want to know where is minus half, right? but you don't know A. So you don't know whether your minus half is supposed to be here or here, on the right or on the left. Are you following me? Okay. All right. It turns out that you got to be sensitive. You got to be alert as well, and that is this magic number here. This information is not given for fun. Okay. In fact, you should know by now. After all these years of doing math, they don't give you information for fun one. All right. So definitely they give you things that you need to use. So A is more than 1. So what does it tell you? Meaning to say, just give a number lah, like say 2. Okay. Then minus A means is minus 2. Simple enough to understand, right? That's all. So you now probably guess that, okay, you know what, my minus half is right here. Okay, so in other words, if I were to put in, hold on, let me try to squeeze in my minus half here. Okay, so if I put in numbers in this range, right, minus infinity to half, into this curve, what could possibly come out of it? Well, what will come out of it will be here. These things, right? All these possible outcomes. All right, all these possible outcomes will come out from there, okay, which is the circle that you're trying to find. Are we all clear? So that's the concept. It's only 1 mark. I don't think we should spend so much time talking about 1 mark, but this is a very important concept, okay, very important. So much so that, you know, some people just give up on, all right, and the answer, you'll be surprised. It's actually, like I said, it's only 1 mark. So it's not hard to understand that answer is a range of GF inverse is going to be lowest A to infinity, inclusive of A. Now, you see, you don't even need to bother what is this point. Don't need. What for? Is this the lowest point? No, this is the lowest point. When you're looking for range, you're looking for the lowest to the highest. Agree? So the lowest is A, highest is infinity, when we're done. That's all. Agree? So nothing to substitute, anything at all. Okay? All right? So let me, just to be sure, in case you're marking on your own, right? This whole set is 1 mark. This whole thing, this answer itself is 1 mark. All right? There's no working for this, to be honest. What working to show? Okay? All right. There you go. This is it. I think we overrun the question, the time limit for 1 question. Any questions? Okay. Now this is a very awkward thing to be asking you guys because I can't hear you, right? So you got a question also, I don't know how I can. Okay, so anyway, never mind. You got a question, we can come back later to talk about and all. Okay, come, let's move on to the next question, shall we? All right, question 2, chop chop. Okay, this one is what I will term it the easier one. Okay, the easier one in the sense that it's supposed to be easy. But if you think harder, right? I have one friend who emailed me, I think Marcus. Are you here, Marcus? I'm not too sure. Right. So he emailed me regarding there's a slight problem with this question. I like it a lot. Okay. But anyway, I shall not discuss that because that will take up a lot of time. So I'll just go through the spirit of this question and what the question really wants us to do. Okay. Sometimes don't think too hard lah. Okay. Anyways, so the idea is this. The sum of the first 2 n terms. Now, it's unfortunate that this setter like to use 2n, okay? But I guess it's just because n is too common. So they want to make it a bit harder for the students, 2n, and make people, not people off balance a bit, you get what I mean? Okay, but it turns out this 2n does create a little bit of an issue. But anyway, if you go by the idea, it's quite simple, okay? And the idea is this. Imagine n to be 10. So we're talking about the first 20 terms. Okay, all right, so there's a formula for the first 20 terms. All right, the kind of idea. So it's a formula. Nobody says AP, nobody says GP. You're supposed to prove it later. So that's my S2N. Okay, just write it down. S2N. Now, there are a couple of ways you can do it. One is you can change it immediately to SN. Maybe you're more comfortable dealing with N rather than 2N, right? I mean, some people. Do you know how to change it from 2N to N? Tell me you know, okay? Just change all the n to m over 2, right? Yeah, okay. So that will work, all right? But actually, you don't have to. You just have to try to figure out 2n minus 1. Okay, 2n minus 1 will be, well, literally 2n. Okay, now this is the part that I saw a few people making the mistake, okay? 2n minus 1 minus 1. And this is the part that I want to spend a bit of time to talk about. Imagine n to be 10. Then 2n is 20, okay? 1 term less of that 20 is 19. Makes sense, right? Everybody understands that. Okay. So why am I telling you like that? That Mr. Ng, isn't it obvious? Like this is 19. Yeah. You see, what some people did was they changed the n to n minus 1. Different, because you can get 2n minus 1 here. Then this is 2n minus 2, completely different answer. Sorry, 2n minus 3. Okay? So you must understand that this is not correct. You don't go and change the n to n minus 1. You just take the whole 2n, whatever 2n is, minus 1 term, which is this one. Get the point? Okay? So but not one fella, at least two I saw, okay? Which is I can't say it's a common problem, but I cannot say that it is something that is very obscure that only one joker make that kind of mistake. Okay, so you do want to be very clear. So if that bothers you, you know what's the next best option? Every time you see 2n, 3n, whatever, always change it to n first. That probably save you better. Okay, change to n first. But then again, this kind of question, 2n is rare. I don't know why this teacher like this. Okay, anyway, so there you go. That's my 2n, that's my 2n. So what I have will be, of course, so-called this formula. I don't even call this a formula, okay? But yeah, this concept that if you add up from first term to 20th term, and then you minus away the first term to the 19th term, you actually get the 20th term. Like, okay, law, okay? Everybody should understand, right? Okay, so some people go careless because they forgot to change the sign when they switch from minus, take out the bracket and all those things. Okay, those are little issues already so I don't nag too much. Okay, so there you go. You're gonna get u of 2n. All right, and in case you thought that this is really hard, it is actually not. You just have to be careful with the power. Okay, so you see that this is actually there's a 3 square somewhere, right? Okay, so the 3 square is actually a 9. The 1 over 10 is a constant, you can take it out. So you actually have a 9 over 3 2n minus away 1 over 3 2n. Okay, so that will give you 8 over 10. 8 over 10 is 4 over 5. No, sorry. 9 minus, oh no, this is not 1, sorry, this is 3. Okay, so 6 over 10, right? 6 over 10 is 3 over 5. Sorry, you gotta help me with that sometimes. There you go. This is as neat as you can look like already. Try not to leave it like that. Why? Because the idea is you need to show that it is a GP later. So you're just kicking the can down the road. Because if you don't simplify now, later you got a bigger problem, right? Okay, so you simplify now, then later on you have a lesser issue. Okay, so I would say that you should face the issue head on rather than kick a can down the road. Anyway, this is not un. All right. This is u2n. Okay, so therefore un. Okay, so this is just one approach, or rather one one option of the working that is possible. Okay, like I said, some people may do a slightly different style. All right, they may not deal with the 2n all the time. They just change it to n straight away from the start. Are we all good? Okay, so take note of that. You don't have to follow exactly like this. Yang Ying, you just ask another question. You need n minus 1. Yeah, later. Not yet. Okay, so I found un first, which is this question, this part of the question. Okay, this part of the question says find un. So I found already lah. Okay, I think I got 3 marks up to here. Right, the next thing I need is to show that as a GP. The concept so far, I think based on what I saw, quite good. Most people know what they need to do. What you want to show, okay, is un plus 1 over un is a constant, okay, or un over un minus 1 is a constant. Doesn't matter which one. All right, just this is what you want to show. Okay, so have that in your mind, like oh, that's exactly what you need to do. Then at least you have clarity already, because the next thing to do is like pretty lame, right? All you need to do is to go and find the un plus 1. Or if you prefer minus, then go ahead lah. Okay. Then there you go. That's my so did I say plus 1? Okay, plus 1. Sorry. Yeah. Okay. Yang Ying, you prefer n minus 1, then go ahead. Okay. So that doesn't matter which one. Then just stack one on top of the other. And your job, or rather what you're looking out for, is to convince people that it is a constant. Constant means nothing to do with n. Okay. Your n must somehow disappear. And it's not hard to see how it disappears, right? This will disappear. And if you're stuck at your law of indices, I feel sorry for you, okay? But you should then do slowly then, okay? So law of indices says that you can do it like that, right? Split up, and then you can see where the n cancels away, right? And you get 1/3. Okay, so you have to explain yourself a little bit and say that, well, since un plus 1 over un is a constant. By the way, this constant has a meaning in the GP, okay? It's actually the common ratio, R, okay? Therefore, a series is a GP. Ta-da! Okay. All right, marks allocation, total 5 marks. Like I said, I will term this as an easy question. Okay, I will so-called classify this as an easy question. Everyone's supposed to get full marks kind if you only study, all right? But then, unfortunately, that's not the case. So how do I distribute the 3 marks? I would say that if you come up with something like this, similar, you will get 1 mark. Okay, so similar in the sense that you may have this version instead rather than the 2n version. All right, doesn't matter. And then of course, putting in the workings correctly. Okay, putting in the things correctly. That means you identify your Sn S2n minus 1 like what I identify here correctly, and putting in correctly. So if you got a sign problem, forgot to change sign or whatever, then you won't get the 1 mark. In fact, the answer is also wrong already. Then of course, getting this itself is 1 mark. Okay, and then the concept of this un getting a constant itself, right, is 1 mark. And then of course the conclusion. Right, if you think about it, this 5 marks is a bit generous. Okay, because this is unnecessary 1 mark. Okay, this conclusion is lame, right? Okay, so but anyway, they give 5. We have to think about how to give the 5 marks away. So there you go. All right, that should be the correct checkpoints. So far so good. Okay. Any other questions? Quick. All right. Now, it may sound like I'm rushing, and it's true. Okay, I'm rushing because we have a lot of questions to cover. All right, and the harder ones I suppose you may have questions, and I want to answer your questions. Okay, so easier ones I'll go through a little bit faster. Let's take a look at this. Vectors. All right. Some people are just terrified of vectors. I don't know whether are you one of them. If you are one of them, not to worry. It's quite normal. Okay, quite normal because vectors is not that straightforward a chapter. It's a very big chapter. So if you're stuck at it, right, my suggestion is you please start studying or revising now. Okay, don't wait until August. It'll be too late, or rather it'll be too stressful. Okay, anyways, this is the kind of vectors question that you hope will not come out for exam, but unfortunately you sure come out on this kind of what I call the no number question. You notice there is no column vector at all, right? There's no like 1 2 3 3 4 1 or whatever. Don't have, right? You want to do a cross product, you can't, because there's no number, right? You want to do a dot product, you can't. You basically can't do anything. Right, some schools call this the abstract vector question. Well, not bad, abstract. They're quite kind of abstract, right? Because got lambda, got A, got B. All right. So anyway, so let's run through quickly. All right. Should not get 0. My idea is that no matter how hard, you should not get 0. Part 1 is a giveaway. Really, giveaway. You have to memorize some things that can't be helped. Okay. For example, geometrical interpretation. By the way, this is very common nowadays, okay? Even in the A level. Very common. They'll ask you, what is the geometrical interpretation of this nonsense? And then you just got to think of some rubbish to come up with. Okay, first of all, you need to understand your notations quite well. First, this is a mod, you know. What it means is it's a number. This is also a number, right? When a number divided by number, you get a number. So it's not a vector, okay? So first of all, establish as a number. All right, next. This is the length of A, or whatever. I have no idea what it means also. A cross B does come with a lot of information. Okay, A cross B comes with a lot of information. I don't know whether you remember or not, right? Well, A cross B mod is actually the area of the parallelogram. This number represents the area of the parallelogram. Okay, it is. Okay, A cross B cap mod refers to this length, which is not the length of projection, but it's the vertical length, if you like. Okay, A cross B cap. You get what I mean? So you must have this kind of immediate relation to see like, hey, A cross B, what the heck does it mean? And it doesn't mean just being able to do the cross. being able to understand what it actually means. Okay, so there are a couple of ways you can do it. No, not a couple, two ways I can think of. Okay, so one is rather easy, and that is this. Okay, okay, you probably can understand that the mod can be taken up like that. Okay, can, right? I mean, it's just you can put the mod together. Okay, and you can see that this becomes A cap cross B. Then you say, Mr. Tang, no such formula A cap cross B. I heard of A cross B cap, right? And if you can recall, A cross B cap is this one. A, this is B, correct? This is the length that is called A cross B cap. Okay? In class, I like to call it the third side of the triangle. If you like, the opposite side of the right angle triangle. Okay, the opposite side. This is the adjacent side, which is the length of projection. So, which is the A dot B cap version, right? So this is the sine version. Opposite side is sine, right? Okay. So that, hold on, that is upside down. Not quite the same. So you just got to re-engineer it a little bit. Okay. So because even though A cross B is not the same as B cross A, they're not the same, okay. But because we're going to mod it, right, we're going to get the number anyway. Correct or not? So the number doesn't matter positive, negative, right? I mean, you're going to mod it, you'll get a positive number anyway. So what does this mean? This is the B. This is the A. Sorry, spell wrong. Okay. And this is the length they're looking at. That's all. Just switch the A with B. That's all. Okay. So what does this length mean? Some people call it the shortest distance between. Actually, the more accurate answer should be the length of perpendicular from B to OA. Okay, it's the length of perpendicular from B to OA. All right. So that's 1 mark. Another way you can look at it is using the area idea, okay? Using area idea, because this is A and this is B, and of course they span out a parallelogram like this. So the A cross B cap is actually the area, okay? And what do you get when you take the area divide by the base? You get the height lah, because area of a parallelogram is base times height, what? Okay, now in case you don't know, and then you better know now, right? Because this is how we find area of parallelogram, right? Don't always think of shoelace method, okay? All right, so base times height is your area of parallelogram. So if you know that this is area of the parallelogram, and then this is one of the sides of the parallelogram, then pretty obvious, once you divide, you're going to get the height, which is the vertical height. And how do you describe that? That's the length of perpendicular from B to OA. Okay, same interpretation, of course, same geometrical interpretation. It's just a different way of looking at things. Are we all good? 1 mark. Okay, cannot spend too long. Come on, let's move on. All right, unless you got very serious question. Now, what I urge you to do is, in case you really got question, and then like before you can even raise your hand or catch my attention, I move on already. You want to write down a question later at the end of it, then ask me. Also can. Okay, so at least you write down, you don't miss it. Okay, if you want to ask, you ask. I'll help you all the way lah. Okay, next one, 2 marks. This one quite sad also lah. Not a lot of people get it. In fact, a lot of people got it wrong. Okay, so what's going on is this: so I find the position factor D in terms of this, that. Okay, where's D? Well, ABCD is a parallelogram, right? So I don't know about you, but I'll feel a lot safer if I just draw out a parallelogram. Okay, so maybe it's me, but I think it helps me lah. Also, whatever floats your boat lah. So if it helps you, you should just do it. Okay, don't care how people judge you. So I want to find D. Okay, what do you think though? Well, the truth is you need to be in terms of A and B. A is A, B is B, right? So it's pretty obvious that maybe I'm going to use AB then. AB is OB minus OA, right? So that's like pretty lame. And then AB looks like it's the same as DC, correct? Yeah, because it's parallelogram, equal length and parallel and so on, same direction and equal length. So DC is going to be OC minus OD. Yeah, okay, cool. Okay, but here comes the problem. You see, I'm trying to find OD. You see the problem? That's the thing I'm trying to find. So actually, now if you think harder, you go like, if they are equal, I can equate them, right? And then I can make my OD the subject. And you're almost done. And you're right. The only problem is you better be able to find OC then. OC. Did they mention anything about OC? Of course, you just have to find, okay, that is OC. So now that you know OC, then you realize that this is DC, and OC is your lambda A plus mu B minus OD. Again, OD is the thing you don't know, all right? Then of course, since AB is equal to, what is this called? DC, correct? Then we understand that B minus A will be equal to this lambda A plus mu B minus OD. And what are you going to do? Make OD the subject. That's all, guys. Okay. So you have lambda plus 1A plus mu minus 1B. Ta-da! Now, of course, you may not do it exactly like me, because some people just don't like to use AB compare with DC. No, I cannot. Can. I mean, who says you can compare like that? DA compare with CB then. CB, circuit breaker. All right, but you get the point. Anything will work, but choose one that's fastest, easiest, safest. Get the point? All right, so I think this is safest for me, because I see my OD straight away, and then I can put in the OOC very neatly and all. But I saw people doing it differently, and then they get the same answer. That's fine. Okay, so how do you mark yourself, right? If you have 2 marks, of course, answer 1 mark itself. The other one is, well, 1 pair lah. Just choose the pair that's correct. Okay, so you've got a pair that's correct, but you can't get the answer. Too bad for you. You get 1 mark for at least getting the concept right. Are we all clear? Any questions on this? Come on, quick one. No questions. Okay. Anyway, like I say, I can't hear you, which is bad. Part 3. Now, part 3 is the hard one, or rather, if I may call it the slightly harder one. Okay, more troublesome. To be honest, it's more troublesome. Okay, well, because you look at the marks, you know, right? 6 marks. Okay, so no joke, kind of. So the idea is this, right? Point E lies on BD produced. So I don't know whether you want to recycle your diagram or you want to draw a new one. Doesn't matter. I tell you what. I probably again should copy and paste the question here, right? Otherwise, I cannot see what I'm dealing with. Okay, so yes, a bit like this. Okay, so E lies on BD produced. So my diagram was a bit like this, right? B and D. Okay, the feng shui. Make sure you get the feng shui right. Okay, so D is here, B is here. All right. Okay, so what do we know? There's a point called E, right? And E lies on it produced means it's somewhere down the road. Okay, whatever. Okay. This tells you the ratio. BD is 2, BE is 5, so that makes this 3. Okay, my proportion is obviously very off, but never mind, not important. Diagram not to scale is fine. So what do we want? They want to find the position vector of E. Okay, so they want to find E first, which is OE. Okay, that probably gives you what, according to my marking scheme, 2 marks. Okay, then the rest of the 4 marks comes from finding the area and then find K. Okay, so let's get to work. First of all, OE. How are we going to get OE? I saw some people, they use ratio theorem, which is awesome. I mean, you have to pretend that's an O there, right? Then you do it. It's fine. You make OE the subject, you get it. All right, those people who did it got it. It's not hard. Okay, but I think that sometimes you don't be over fixated over this. I must use a formula. No need one. Okay, because if you look at the situation you have, right, you should exploit the fact that you already found B, you already found D. Okay, and the fact that you know the ratio allows you to actually write down an equation very quickly. So for example, what I mean is BD over depending on what you want, BE. Okay, I'll use BE rather than DE, because B is just B, where D is this nonsense. So I'll avoid using this nonsense as far as I can, right? Agree or not? All right, so you should use the more friendly one. So I don't mind seeing a lot of B. Okay, get it? All right, so I probably won't mind seeing a lot of B, but I don't want to see so many D's. Okay, so what I mean is this, right? BD over BE, right? It's going to be 2/5. I form it this way. Now, like I said, if you don't like, I almost wanted to say if you don't like me. No, I mean, if you don't like what I wrote, you could have wrote it this way, right? This is 2/3. And it will work. This is correct. Nobody can say you're wrong, right? But you're just making your life harder because you have D to play with more, right? Get the point? So try to strategize in a way that you have less chance to make a careless mistake. Make sense? Okay. So there you go. BD. Okay, by the way, you should draw arrow. Okay, I always scold people on the presentation, then me myself like that. Okay. BD is this nonsense. Bear in mind, also be very clear about what the heck you want. This is what you want. Okay. And do a quick check. If this is what you want, the rest you have or not. B have, B have, D have. Everything also have. Just making OE the subject. That's all. Okay, so it's not that hard. In use ratio theorem, it will work out to be the same anyway lah. So my point is, I show you one method enough. Otherwise, you go crazy. Do until 12 midnight also cannot finish. All right, so this is going to be OE minus OB. Follow or not? Okay, so I don't know how you want to do this lah, but obviously you need to make OE the subject, right? So slowly do, also no big deal. Okay, so OD. Oh great, I forgot my OD. Hold on. That nonsense right there, right? Can you see that? Okay. Alpha, sorry, lambda plus 1a. Hold on, now I cannot remember. Mu minus 1. Okay. So plus mu minus 1b minus another b is equal to 2/5 OE minus 2/5 b. Is it so much better to be dealing with wrong with b, right? Rather than all the other people. Okay, so what do you want? 2/5. Do slowly, this kind of thing, if you do wrong in exam, is just very painful, right? So it'll be, hold on, sometimes I can do wrong, don't laugh, okay? Mu minus 2b, and then what do I have? Plus 2/5 b, correct? Okay, all right. Can we simplify this? I'm sure. Okay, so we're gonna have minus 2 plus 2/5. Oh my god, that's really hard for me. Hold on. Minus 2 plus 2/5. Anyone knows the answer? You know what? I think I have this problem since primary school. I can't sort out fractions. So if you can, that will help me a lot. 2/5 minus 5. Correct, huh? I see I press those can press wrong. This is embarrassing. 2/5 minus 2. Yeah, right. Minus 1/6. What the heck is that? 4 over 8. Okay, 8 over 5. B. Okay? And then I'm going to times 5 over 2. And this is my OE. Okay? You know what? We should clear things up, right? Should we? Yeah, I think we should. Because I think we need it later. So we should not try to kick the can down the road all the time. 5 over 2 mu. And minus 4. Whole number, finally. Yes. This is your OE. Questions? Okay, 2 marks only, up to this point, only 2 marks. Okay, how you allocate 2 marks? Of course, getting the OE itself is worth 1 mark, right? And the process of getting it, that means to say, whether you use your ratio theorem or use this kind of cheapskate ratio, okay, to help you form the equation, this is 1 mark law. Because it's correct kind already. You understand? Ratio theorem will look very sophisticated. But it's unnecessary. Just make your life look like a little bit more advanced, but actually it's not that hard. Okay, so there you go. Now then we move on. Not done yet. Oh, great. Where are we now? We found, okay, hence or otherwise, determine the area of the triangle BCE. Great. You look at this picture. There's no C, right? So I probably should trace back to see how my C look like. Oh, C is somewhere there. Okay. So accordingly, C is somewhere here lah. Oh, okay. So triangle BCE. Okay. Looks like this. Sorry, somehow missed the point. Okay, here we go. Okay, cool. That's the area of triangle. Now, in vectors, every time you are supposed to find area, right? The first thing that comes to your mind is the cross product. Make sense? Okay. So cross product allows you to find area of the parallelogram, but you're looking for a triangle, so half it. Agree? So in other words, you better have some sense that I need to find the sides, either BCBE or ECBC. Any 2 sides will do. Okay, any 2. So again, you want to be on the hunt for the easy one. I said, what for? You're going to make your life harder, right? Like purposely going to find the side that's so hard to find. So I will think that since I already have OE, pretty obvious it's a hence question, right? So I think I'll use BE. Since B is just B, right? So remember that one? Okay. So I'm going to use BE cross BC or EC. That one up to you, okay? All right, but I would think that BC probably looks easier because again, B is just B. Okay, E looks like this. Okay, C looks like this. So you want to use that pair? Okay, so my point is, even you choose the pair that is functional. Okay, or not functional, everything is functional. It's just that choose the pair that helps you do things faster. This is what you're trying to do. You write down this, you get 1 mark. Understand? Okay, again, the spelling doesn't matter, right? You can be any other spelling. You like EC so much, you can put EC then. It's just that your life will get a bit harder if you want to find EC lah. Alright, well, I find BC will be a bit easier for me, right? Get the point? Okay, cool. Alright, then we hunt down this joker. Okay, well, in order to do this, pretty obviously, you need BE. BE is OE minus OB, right? And there you go. All right. So thank goodness I clear it, right? Because now it looks so much easier. Minus OB. Can you see that? And please tell me you can simplify this without calculator. Agree, Minus 5. Okay. This is my BE. 2 lines only. Okay, next BC. BC is OC minus OB, right? What the heck is OC? I forgot again. OC is this one. Okay, this one, lambda A mu B. Okay, that's my B, OC. So lambda A mu B minus B. Can you simplify this? Sure you can. Lambda A plus mu minus 1B. Ta-da! You got all the ingredients you need to do the area already. You realize? Just have to put it in. Right? Like baking cake like that lah. Follow the recipe, but then you must have the ingredient. Nowadays, I tell you, all the neighbors all become good bakers. Okay, so we have half. Gonna mod. Better remember mod. Mod is not optional, okay? It has to be there. Otherwise, you're gonna get a vector because when you cross, it's a vector. Vector how to be area, right? Okay. So be brave, okay, and be careful because anyway, I didn't see a lot of people getting this part right, to be honest. One friend I remember quite well, she came quite close, but then she got careless somewhere in between. So that was quite unfortunate. Okay. Other than that, this is a disastrous step. All right, so you just have to be brave. Okay, be brave in the sense that hey, I'm just going to take this, cross this, write it down lah. Understand? Whether you can do or cannot do that one later. Understand? But at least you write it down. Don't write down also can write wrong. And then GG already. Right? Don't even need to continue. Okay, now we need to expand. Okay, because you must understand what the question wanted me to do. No. Okay, the question wanted me to do like that. At the end of the day, all right, you are supposed to become like this. You cannot figure out what is A cross B because nobody knows. So you're going to leave it alone. Who cares, right? But you need to figure out the K. So K is supposed to be what again in terms of the lambda and mu and all those rubbish, right? Yeah. So you see a lot of lambda, a lot of mu anyway, right? So you know you're more or less there, but you just need to expand and figure out the K now. Agree? Okay. So follow me. It's called the eyebrow eye back expansion. You learn in Sec 2. Same, all right? If you like, proper name to this is called the distributive law, okay? Anyways, you better remember that A cross A is equal to 0, okay? In other words, by the way, this 0 is a 0 vector. It's not a 0 number, okay? Because when you have A cross A, it's a vector. It's not a number, all right? So that's why when you see in notes, the 0 is always in bold one. And when you write, you should write 0 with a flying carpet. All right, don't think there is a number, okay? It is actually a vector. But anyway, never mind, because anything that vector 0 also becomes 0, so it's okay. Most people get past it without harm anyway. Okay, so my point is this. This times this. Don't even bother writing it. What for? It's 0, what for you're going to write? Okay, so what you want to focus on is this times this. Okay, and of course, when I say times that's cross, right? You do want to know that there are some properties that can help you, right? For example, you should know this. If you have constants, You can take out the constants. I don't know whether you know or not, but you better know now, okay? So if you don't know, then now you better know. Right, so these are constants, guys. That's all, okay? Keep your focus, all right? Your mind must be like, hey, you know what? I'm just going to have all this bunch of constants, and I'm going to end up with A cross B. Isn't this? Okay, it just look very messy, right? Yeah, but that's it lah. It's not hard, what? Okay, come. Next one, this one. After you draw the eyebrow, you draw the eye bags. Okay, there you go. The dust, this one don't bother, right? Because we know it's zero, zero vector or whatever lah, just zero. Okay, so we're gonna end up with 5/2 mu minus 5 times lambda times B cross A. Okay. And if you are alert enough or sensitive enough, you know you're getting the answer already because the K is just there, all right? Then you have another set of problem, which is this is different from this. But this is a much easier problem, to be honest. What I mean is okay, we should do concurrently at the same time. So meaning to say, what I would do, let me think. I should take out the 5/2, I think so. I hate fractions, really, I don't like it. So I'm going to take out 5/2, so it make my life a bit easier. Okay, so I don't have 5/2 here. Yes, okay. So I'm going to have lambda mu minus lambda plus mu minus 1. B cross A. Okay, and then this fella got 5/2, but this fella doesn't have, right? But it's a smaller problem lah. Okay, so I'm going to get mu minus 2. Okay. All right, mu minus 2 lambda. Okay, so that when I multiply in the 5/2, I get back the same value as before. That will be fine, right? Okay. And at the same time, I'll change this to minus so that I can have A cross B rather than B cross A. Okay, so see how I changed the green color part? It used to be different, now same. Okay, not that painful, right? Okay, good. And of course, this one, in case you're confused, is actually a very simple idea. It's like having you 5A minus 3A like that. What do you get? 2A lah. Oh, sorry, I can't believe myself. Okay, 2A, right? Okay. So this is like the 5, this is like the vector, and then this is another number, another same vector. That's all. Okay, just minus. Primary school kid also know. You better know. All right, so we're going to have 5/4. All right, and it's going to be lambda mu minus this plus this minus this, and then minus mu plus 2. Why is there plus 2? Looks correct. Anyway, I also don't know. Let me check the answer later. And then we have this. Okay, and then do you think we sort of saw a K, not K, sorry, what's that called? K, yeah, sorry, I was trying to find K. This one cancel, right? Sorry, I have a careless mistake already. I realized I haven't expanded that thing. One more time. This one, yeah, is a mu lambda, then plus 2 lambda. My bad. Okay, sorry, my bad. Lucky I spotted it earlier. Okay, then right, lambda mu cancel. Yes. What is left? 1 lambda, 1 mu, minus 1. Lambda plus mu minus 1. Okay, cool. You may want to do it this way now, since they literally ask you for K. So that is your K. Okay. Questions? Okay. My students, you're in the class notebook one, right? Don't need to copy, okay? All these are there in your notebook already, okay? So don't waste time copying. Wait, copying. I'm busy and no chance to ask a question. Don't worry, you can copy it later if you like. It's all there in your OneNote, okay? And for the rest of you who are not in the OneNote, it's fine because it's going to be recorded and then you got the video, right? You can pause and copy all you want, okay? So copying is not the main thing you want. What you want to get out of this is, do you understand? Okay, do you understand what I'm doing? Do you understand what I'm talking about? You think if this question were to come out again, can you do it all by yourself? That's the question you want to be able to answer. Okay, so now the truth is it's not easy. There are so many places for you to get things wrong. Agree? So many places. But that's why I say you try to optimize it to a way that is easier to do things rather than harder. Okay, so it's a 6 marks question. So how many marks I give out already? Okay, so you can guess lah. All right. This one 1 mark, 2 marks, 3 marks, right? And I'm sure. I mean, of course, identifying K itself is 1 mark, right? Pretty obvious. That's like the answer mark. Answer always got 1 mark, right? Okay. So K itself is 1 mark. The expansion, okay? I would say that the expansion from here to here deserve 1 mark. Okay. Test you on your courage. And then of course the ability for you to be really cool about changing the B cross A cross B. I think that deserves 1 mark also. Okay. So we are done. 6 marks. All right, so expand correctly, 1 mark. Being able to change the minus to plus, plus to minus, or whatever. Okay, 1 mark because you need that. That is part of the deal. And then of course the clearing up of all the things. So 1, 2, 3, 4, 5, 6, 6 ticks. Yeah. Okay, there about. Any questions? Okay, no questions. Let's move on. All right. Next one. Favorite, right? Complex number. GG. See, hang. Sorry, this one also allergic to maths. Let me reload this a bit, okay? My bad. Anyone got a question? You can actually ask now. I'm just very puzzled by why I cannot hear you guys today. Okay, I really don't know why. It's something I don't like because I'm like talking to a black hole like that, right? So in any case, you know, ask question or whatnot. Please try your best to ask. Okay. All right, question 4 now, complex numbers, right? This is not the harder one. I think the harder one that nobody get right is question 5. Okay, 5 last part. So let's talk about this quickly. All right, what's going on here? The complex number given by this is not hard because it's not very mysterious anymore. When they give you a number, that's it, right? It's a complex number. In the Younger diagram, mark and label the points, this, that. Okay, so we have Isaac. You better know what Isaac means. Isaac is a 90 degrees anti-clockwise rotation about origin for Z, right? And Z plus Isaac. You also better know what it means. Okay, so anyways, it's a 2 mark question to draw. So you should have a sense of where your root 3 is. So root 3 is about longer than 1, so you probably want to draw a bit like that. Okay, so that is your root 3, that is your 1, and this is Z. Okay, all right, you can label it that way. If you want to do the dot, 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 go ahead, but my diagram may be too small to do dot, 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 so I just leave it. Now, what you want to understand is that, sorry, wrong, -1, oh dear, sorry. It's right here, right? Okay, so it's here. This is the Z. Okay, almost died there. Okay, all right. So usually you may want to just link it to the origin. Use dotted line to link it to the origin, which may not be a bad thing because it helps you draw nicer pictures. All right, because Isaac is going to be the anti-clockwise rotation of this dotted line. Okay, anti-clockwise 90 degrees. So if you have a ruler, right, you place your ruler here, and then you probably can draw quite nice and neat one. Actually, the truth is nobody cares about accuracy. All right, but what is more important is really about the labeling. All right, label the 90 degree, please. Okay, you should be confident that it is 90 degree, unless of course you're not sure lah. Then this is Isaac. Isaac is X. Okay, and if you like, you may want to also indicate that they're equal in length. Okay, because rotation does not affect the length. Agree? When you rotate, it doesn't become bigger, you know, or longer, you know. Okay, so rotation doesn't affect the length. So OZ is the same as OX length. You just move. It's like compass. Okay. Now there you go. That's X, which most people will get 1 mark for doing this lah. But unless you never draw the 90 degree, you don't get 1 mark. Okay, the 90 degree is important. Okay, right. Next is a Y. Now some people get lost here. They don't know what to do. You know what they did? They literally go and calculate because they got Z so they're not worried, right? So they calculate lor. And since I got GC, they also not scared. Sorry, I don't know what I'm writing. Okay, root 3 minus 1, right? And then they go and Isaac plus Z, no? And then we work out this rubbish looking coordinate lah, okay? And then somehow this rubbish looking coordinate look like it is somewhere here. I don't know lah, okay? Then they just draw. Now, concept wise, sorry, that's not good. Okay, I can't say you're wrong because the question only asks you to draw ma. So if you draw a point that looks like it is there, you call this y, all right, and you dot 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 dot. Nobody can mark you wrong, you know. But if you don't know how y is related to x and z, then unfortunately you're doing yourself a disservice. You want to know that there is a very clear-cut relationship between them. Okay, and that is this. Okay, pay attention. It's called addition law. All right, addition law in the sense that your oy, if you think in terms of vectors, oy is actually z plus iz. In other words, if you want to think like vectors, this is iz, this is z, z plus iz is the diagonal of the parallelogram. All right, so that's what you're supposed to know. Nobody going to ask you to work it out. Get the point? You don't go work it out, you know, like, oh, get the point, it looks like that. Yeah, okay. So, but then again, working it out does work because you get the correct drawing, then the question asks you to draw. But more useful, and in fact, I'm actually looking for students who know that they is talking about the diagonal. So if I see this diagram, I'll be very, very happy. Yep, because it shows that you are confident. We are clear, it's the diagonal, confirm. All right, of the parallelogram, turns out it's not a parallelogram, it is a square. But anyway, the one later, 1 mark. All right, so there you go. If you draw it here correctly, I would say that the 90 degree is important. So I'm very stingy. If you don't never put a 90 degree, I won't give you the 1 mark. Okay, because come on. Can somebody just draw that and then just draw like that and then tell me this is x? Can give 1 mark or not? Maybe he didn't even know that it is 90, you know. Yeah, I don't think he deserves the 1 mark already if he doesn't know it's 90. Okay, all right. So you better know that it is 90 and therefore you deserve that 1 mark that is allocated. Okay, but then this one I tend to be a bit more lenient because if you draw like that, like a diagonal, you obviously get a 1 mark. Even if you don't draw a diagonal, you just draw like that, I also give you the 1 mark because maybe you know it's diagonal, all right? Okay, so but anyway, that's it. 2 marks for this diagram. Very easy to diagram actually. All right, part 1. The answer is a square. Okay, and that's it lah. Okay, 1 mark. So, but they actually mentioned something about state with a reason. Yeah. Okay, state with a reason. So you probably have to give at least a reason. So you can say that OZ is equal to OX. Okay, and angle. And hold on, what else? OZ equal, and then an angle, angle what? ZOX is equal to 90 degrees. Okay. Actually some more because these two alone doesn't make it a square. And since OY is a diagonal of the parallelogram, something like that. Okay. So it's a square. But I tell you, this is only 1 mark. So if you give some reasoning, along this line, like equal length or 90 degrees, I think that'll be good enough. Okay, it's just 1 mark, really. Nobody asks you to write an essay for that 1 mark. Are we all clear? Can? All right, so geometrical representation means it's a square, all right, but please make sure you know why it's a square, okay, because equal length, all right, and the 90 degree. The 90 degree is important, okay? All right, let's move on to part 2. Using your Argand diagram. Now, this is interesting. Determine the argument of z plus iz. So I have students who very interestingly say from the diagram, okay, the argument of hold on, I can't remember what they do. Argument of z plus iz is equal to tangent inverse, don't know what square root something lah, and then square because they go and work it out just now. I told you, right? Some people, they go and work it out already. So they actually have the coordinate of the z plus iz. Then somehow you know what surprises me is this they know this. I wonder how. This is not special angle. You really memorize this? Or your GC is capable of giving you pi over 12? I'm surprised. So obviously they are working towards the answer. Okay, they probably get some rubbishy number here, and then they just try their luck now, divide by pi. And then hey, it's pi over 12. Okay, then that's the argument. Sorry, that will not make the cut. Okay, so this is not guess and check. I won't give you the marks. Not convincing. Okay, so it's not convincing. This is rubbish. Okay, this is like guessing the answer. All right. So nope, that's not the way to do it. This is from diagram. How you take projector and measure. So the idea is a little bit more, than that, and that is this. Okay. And unfortunately, I haven't seen anyone doing this. This is what you want. Go and do it. But then using your diagram, how do you use diagram? Right? Okay, pay attention. We all should know that this is this z1 plus I. Agree? Can factorize out, ma. So then we also know that argument behave like log. Agree? Okay. So argument of z. Do we know what is argument of z? No, I mean z is this number, right? And it turns out that z is not a difficult number to play with, because after all, this is a special angle. Okay, 1/√3 is special angle. Come on, this one, this angle right here. Okay, so if you tangent inverse 1/√3, you're going to get special angle pi/6, but it's negative. Okay, so this nonsense is pi/6 negative. This one is pi/4. 1 plus I is pi/4. You better know, right? So you get pi/12. You can find that. Okay, all right, you can find that. Not much of a reference to the diagram, actually. I don't know how the diagram is going to help you, really, to be honest. The diagram helps later, this part. Okay, this part, yeah, probably, yes, because you need the diagonal feel to it. All right, so this is how you find the argument in a very convincing manner. Okay, next one, that is probably where the diagram comes in handy. All right, and that is the z plus iz. Which some people already did right from the start. Okay, so this is z plus iz. So I'm going to get this minus plus √3i minus I squared become plus 1, right? So I'm going to have 1 plus √3 and then plus √3 minus 1i. Okay, so this is the z plus iz. And I think what they are trying to prompt you is to let you think about what is z plus iz. Z plus iz is y. Okay, all right, we're supposed to know already. So that's how things all link up. All right, and the argument of y, which is this z plus iz, is this angle called pi/12. Understand? So the pi/12 is actually squeezed there. This little angle here. This is your pi/12. All right, and what you want to link up together is, all right, is the fact that if you know this is your y, that means you know that this coordinate, the x coordinate, is 1 plus √3. The y coordinate is √3 minus 1. And therefore, you should be able to spot the right angle triangle, and this is the angle pi/12 that you are trying to do what? Tangent. So therefore, all in, right, together with the diagram, is obvious now that if you do a tangent pi/12, we're going to get opposite over adjacent. And the opposite side happened to be √3 minus 1, and this is 1 plus √3. This is, I think, what they meant by using a diagram. Understand? I'll not use a diagram to go and measure the angle. Doesn't make sense. Clear? Okay, all right. So from the diagram, you see a right angle triangle there, right? And that little angle there is called pi/12, right? And once you know the height, the breadth, or rather, if you like, the height, opposite side, adjacent side, you can do your Picasso, that's all. And that's exactly how you're going to show the last part. Hence means we figure this out, we figure that out, we look at the diagram, and then we figure this out. Are we all clear? Okay? So it must make sense. You know, aga, tikam, you know, like, do this first, do that first, anyhow, I guess the answer pi/12 somehow magically pop up. Okay? Because, okay, this is not the real A level, of course, right? My point is that since I'm spending the time to do this review, I want you to learn the right thing. Okay? Rather than to just, oh, answer correct, okay, I'm not correct. Okay? I want you to make sure you think of the process correctly as well. Okay, 5 marks, how to give. By the way, the square answer is 1 mark. Okay, so 5 marks, definitely this one is 1 mark, I can show, right? If you rationalize, you get 1 mark. Okay, and I don't know how to give out the marks already, okay? This one deserves 1 mark, huh? So somehow your working got this, you worth 1 mark. Only 3, I got 2 more to give. how to give 2 marks like that? Okay, so I suppose this idea of being able to use your argument, right? Find argument confidently, split it up, things like that. I think this is 1 mark. Okay, and of course, being able to find the argument, because that's the main job actually. Determine the argument, then you better have a step to show how you get the argument. Correct? I'm not playing around with the calculator and get pi over 12. That doesn't count. Okay, so yep, 5 marks. How else you want me to give 5 marks, right? Okay, or you think this deserves 10 marks? No way, man. Okay, so you must know what you're dealing with. Okay, so this is complex number. Okay, one of the reasons why complex number is hard as a topic is because these 2 questions, question 5, question 4, are both complex numbers, but they are very different. Okay, they're so different. So you can do the previous question, doesn't mean you can do the next question. All right, so let's move along. All right, are we halfway there? 5, I think so, right? We got like what, 11 questions to do. Okay, so now this one, the worst done part is actually part 3, to be honest. Nobody get part 3 correct. A lot of people just give up. But anyway, probably because 2 marks, right? 2 marks, then you don't know how to do is skip. Right? In exam also like that, right? Just skip. 98, still A, what? Correct? Yeah, nobody else will get 100 anyway. So 98 is still A, so that's okay. Skip is fine. It's a good strategy. But when we want to learn things, we want to get 101 marks. Okay, so part 1 is actually quite well done. So that one easy. Let's go through quickly. Okay, so the roots of these cubic equations are this, and this. All right. Given that one of the roots is this is called factor theorem in secondary school. So you can actually let fx if you like. So it can be more secondary school. Sorry, not fx, fz. Okay. It can have a more secondary school feel to it if you need to lah. Okay. So some people like it like that. So you put in f equal z equal to I, and that's it lah. Okay, it's called factor theorem. I don't think I need to review what the heck is a factor theorem, right? Because you start in the root, you get 0. Okay, so if you got this, it's 1 mark. Then of course sort this out lah, work this out, and then get the answer. Okay, I cube is minus I. This is minus ki. Okay, and then 5i plus 3ki. Oh, great. Okay, then what I'm going to get? I'm going to get 2ki plus 4i. Correct? I is not equal to 0, so don't care. Factorize out, we get 2k equals to minus 4, so k equals to minus 2. Ta-da! Okay, cool. 1 mark, 2 marks, we're done. Okay, let's not waste time. Let's move on to part 2. Part 2 is a bit more fun. All right, given that the argument of this is less than the argument of that, okay, whatever. What is Z1, Z2? Z2 is the other 2 roots. That's all right. So a cubic equation, we have 3 roots. Agree? That's called the fundamental law of algebra. Okay, fundamental theorem of algebra. Okay, but never mind that. So I got 3 answers. I only know one of the answers is called I need to find the other 2 answers or not. It seems like we have to. It's a secondary school problem, really. That chapter called polynomial, right? If I give you a cubic equation, then I say, hey, one of the roots is 2, find the other roots. You know what to do, right? You first of all go and do long divide to get the other factors out, and then the other factor out already, you go and do or whatever lah. Go and factorize some more, that kind of thing. It's exactly the same, folks. Exactly the same. Why can't you do it? Okay? So the only difference is it's got to do with I, right? Okay. So anyways, let me show you quickly. Since now I already know my k, right, I should rewrite this. Hold on. Minus 2i z squared. Sorry, in case I transfer the information wrongly, that'll be very disastrous. Agree? Okay, so you want to be a bit more careful. All right, so we know that this is a cubic equation, right? We are old enough to deal with I. Okay, so what do we know? We know that this is a factor. Okay, so back in secondary school days, you can do your long division, you can do a synthetic division, or you can do comparison. All right, so all will work. Okay, so I'm not gonna about to show you all 3. Okay, and I don't like long division. Those of you who know me long enough, you know, right? Because I always get it wrong. Okay, so for me it's called wrong division. So I don't like wrong division. I like synthetic division more. But then I also realize that some of you are not my students, so you may not know what the heck is synthetic division. Maybe you don't even know how to spell. So I'm going to show you an in-between, which is comparing lah. Okay, but when I say comparing, some joker really go and literally compare. That means they literally expand and compare term by term. Please don't do that, okay? That is really for amateurs. Understand or not? Okay, so you are more pro than that. What do I mean? Now take a look at this. This is cube. This is z. This must be quadratic, right? Okay, pretty obvious, huh? And this must be z square. Okay, all right. And then we have az. All right. Some people like to put a plus b. Actually, no need one, because all you need to pay attention is this. This must be 6 law, correct? So it's not that hard really, because the moment you write down, you already have like a lot of the quotient. If you do a long division, this will come out in the quotient, right? So a lot of the quotients are already there. You just need to find out what's a. That's all. Okay, and finding a is actually easy, you know, because you just have to sub in any number you like. For example, sorry, I'll come in the handwriting like that. Okay, one more time. Sub in z equal to any number you like except 0, because if you sub in 0, genius, the a will be gone also, right? Yeah, so that's not a very good idea. So you're going to sub in x equal to 1. Of course, if you like the number 1 million, you can. It will work. Okay, so don't. Okay, so there you go. All right, that's what I will get on my left. What I get on my right is going to be 1 minus I, and this is going to be 1 plus a plus 6. Find a. Oh, Mr. Ang, this is really hard. Chill, guys. Chill. Mr. I'd rather do long divide. Honestly, I still would not prefer long divide. Okay, take a look at this. On the left-hand side, what do I have? I have 6, correct? Correct, what is this? 6, 6 minus 8i. Agree or not? Okay, so 6 minus 8i. I'm going to just go to my GC. Hold on, my GC disappear again. Okay, 6 minus 8i. Oh, sorry, I should put bracket. All right, 6 minus 8i, close, and then divide by 1 minus i. Okay, there you go. Oh, sorry, I forgot to open the bracket. Okay, so this kind of thing nonsense happened. Okay, here we go. All right, that's 7 minus I. So 7 minus I is my a plus 7. So a is equal to minus I. Okay, now. All right, so not difficult, right? So in other words, I already factorized my cubic already. So my cubic looks like this now. Z minus I, z square minus iz plus 6 is equal to 0. Now, if you are looking for the other two roots, then you should focus on finding this. Agree? That's all. All right. So you say consider or considering or whatever lah. Consider this equal to 0. Solve this. Don't bother try to factorize this. Just use formula. Don't waste time. Okay. So you're going to use minus b plus minus the square root of b square. Be careful. Okay, write like that. Okay, b squared minus 4ac over 2a. All right. Now, of course, the negative doesn't matter. Okay, but I purposely write it because I think it can be confusing for some people, right? So you're going to get I plus minus 24 minus 1. That's like minus 25. Okay, so you're going to be minus 25 inside lah. Okay, don't be overly shocked. Hello, you're A level, okay? So this should not shock you, okay? All right, so you go like, okay, 25. 25 is 5i, right? Take a look at this. This is 5i, okay? So 5i plus I, that's 6i. 6i divided by 2, that's 3i. All right, then you have 1 minus 5i, that's minus 4. Minus 4 become minus 2i. This is your z. The other two z, z2, z3, okay? One of it is z2, the other is z3. I don't know which one is which, but we need to find out now because we need to sort it out, right? Yeah, see? You need to label who the heck is Z2, who the heck is Z1, sorry, Z3. Understand? And they want the form in the form of whatever. Okay, so my point is, you can't just leave answer like this. We have one more thing to do. Okay, one more thing to do. And the one more thing to do is sort it out. Okay, so sorry, I'm going to scroll like that. So, okay, here we go. The 3i, you better know how 3i change to the how to change the 3i into exponential form. Okay, so I probably want to remind you like that. Okay, so 3i is right here on the Argand diagram. Okay, so the pretty obvious is that argument is pi over 2. So your 3i is 3ei pi over 2. Okay? Your minus 2i is a purely imaginary number, which means it's on the imaginary axis. So it is right here. So pretty obvious. Minus 2i is minus 2i is 2ei negative pi over 2. Please don't write this. What's the difference? Miss Long is negative what? Why negative disappear? That means your concept is completely gone, okay? This is R. R is never negative. Okay? R refers to the distance from origin. So how does this make sense to you? Okay? All right? So you better be clear. The concept must be clear, all right? So the complex number is complex number. They don't call it simple number, right? Okay? So anyways, which one is Z1, which one is Z2, right? We're going to go back to the description one more time, okay? So argument of Z3 is supposed to be bigger. Okay, so the one bigger one is Z3. Okay, I identify already. So Z3 is this fella. And this identification is important, no? Because the next part of it, you identify wrongly, you're going to get it wrong, okay? So, ta-da! This is my Z2. This is my Z1. Sorry, Z3. Okay. 5 marks, right? Hold on, is it 5 marks? I forgot. 4, only 4. Okay, so how am I going to distribute the 4 marks? It's like now we have the loot, and then we have to try to distribute the loot, right? I would say that's pretty obvious. Being able to factorize it up to here deserve 1 mark. Okay, and something in between, all right? That means to say whether you are using comparing or long division, the attempt of doing long division deserve 1 mark also. Okay, that means the attempt of you doing, but then you may get it wrong lah. Then when you get it wrong, then you'll get this 1 mark. Okay, so but the attempt of doing it, at least you know the concept of what to do. Okay, so I think that deserves 1 mark. Pretty obviously, like the identification of your Z3 and Z2, okay, must be 1 mark each as well. Which also means quite sad, meaning to say if somehow this were to be wrong, everything else wrong already from there on. Okay. All right. I don't think you have any questions because half the time I ask people a question, nobody answers. But I'm going to ask you this one question. Okay. I want you to think about it. All right. We were lucky. We're lucky. Why? I mean, come on, lucky. Like we all know that this is 5i, right? Okay. Plus minus 5i. What if? Sorry. What if somehow you work out a b square minus 4ac inside, right? And you end up like this. You can do? Think about that. Okay? Start or not? May happen or not? Why not? I mean, come on, who says b square minus 4ac must always give you a number, right? Okay? Sometimes b square minus 4ac can have I on what? Okay, and then when the I like that, what to do? Okay? We obviously learned this in class before, okay? So if you don't know, it means you have to revise, definitely. All right, but this is a teaser, go and think about it, okay? So, all right. This is 4 marks. We have one last 2 marks to go, okay? Which is show that, and these 2 marks nobody got. So far, I mark, nobody got anything done for this, which is a bit disappointing. Which I suspect because people don't even know what to try. Okay, don't even know what to how to try, like just skip 2 marks. Okay, so let's try. Let's discuss. Show that this is an imaginary number. You know what the heck is an imaginary number? Okay, let me just write down WTS. Okay, want to show. You want to show that this plus this is equal to don't use K already lah. What other number? Alpha lah, okay? Alpha I. Okay, it looks weird. Okay, never mind. AI. It looks very weird also. KI. Okay lah. Sorry. K is used in the question, so we don't use K, confusing, okay? HI, where H is a constant. By the way, this is what you want to show, okay? Hi. Okay, cool? All right. How to show this? And that's the question, right? How do we do this? Okay, first of all, can we identify who is Z1 first? All right, so if you don't even know who is Z1, you're quite dead anyway, right? You're quite dead from the start. So Z1 turns out to be the I that were given in the start. Z2 was the Z that I found here. Where is it? Here. Okay. Minus 2i. Correct? Okay, now in class, I did mention before that every time when you are dealing with a complex number question that has got to do with powers, right? Your exponential form is your best friend. Did I say that before? I think so. Okay, and I think it is still true. Okay, it is still true in the sense that well, you should play around with the exponential form a bit. Okay, but sometimes you got to be a bit more flexible. All right, in the sense that whatever that works, just work lah. Okay, so I don't know how you want to do this. In fact, when I was looking through this myself, there are more than one ways to do this to confirm. Okay, so there's a Trigo way, which is a bit longer lah. So I'm not going to go through the Trigo way because it takes a bit longer time and unnecessarily troublesome. And worse, if you don't like Trigo, that's worse. Then there is this other way where I'm going to show you now. Okay, so the idea is this. Z1 to the power of this plus Z2 to the power of this is equal to I to the power of this plus minus 2I to the power of this. Do you agree? Not hard. Okay, not hard. Now, then, okay, then what? Then you think, you go like, okay, wait. Do you see common factor? Say yes. Yeah, that should be. Because by your law of indices, you say that I can do a split. Agree? And then this becomes your so-called, sorry, what am I doing? I'm a highlighter. Okay, here we go. This becomes the common factor, which pretty obvious, you can factorize out. Okay, which will give me 1, and then plus a negative 2 to the power of this. Okay, follow? Then now what? Okay, now this is how you want to sell your things. I imagine you're a salesman now, okay? So you need to be convincing. Yeah, you need this from me. You need to buy it from me. That kind of feeling, right? You just have to convince people. All right? How? Remember, what is your job? Okay, your job is to show people that at the end of the day, it's going to be something I. That's it. It's just going to be something I. Okay, so keep your focus on that. Right? This is the banner that should be up here, right? This is the part that you go like, hey, that is your main target. Now you come so far, you cannot say that you are actually very far away from the answer. It's not. You see, that's the I staring at you right now. That's I. And no matter what n is, the I is going to be there, right? The I is not going to disappear. All right? Correct? So you're already halfway there. Don't you realize the I is confirmed there? You just need to convince people that, hey, guys, this is never going to be 0. That's all. Because if this is never going to be 0, I don't care positive, negative, or even I don't care. I just want to know that this cannot be 0. Because if this is not 0, and then therefore this is always I, for whatever n may be, then I have my hi already. What? Clear? Okay. All right. So how we convince? All right. You got to be convincing lah. All right. First of all, what did they say about n? Okay. This is important. Okay. N is not real number. N is an integer, which means if n were to be an integer, this 2n plus 1 is an odd number. And that's important, because when you have I squared, it's suddenly no I already. The I disappears because I squared is minus 1, right? So when you got I power 4, it becomes real. Or even power, it becomes real. Get it? Okay. So you got to be very clear about, hey, you know what? I need to keep the I. Otherwise, I cannot see, right? Okay, anyway, my point is that you need to keep the I, right? So you need to have the power to be odd. And the power is odd. You just need to say, okay, so you're going to say something like this, right? Since n is an integer, okay, 2n plus 1 is odd. And that's all. Therefore, I to the power of this is going to be, okay, running out of letters, I don't know why. There are 26, but somehow I cannot think of, P lah, I just use P, okay, Pi, okay, for some value of P. In fact, P you don't really care what's p lah, okay? Real value or whatever, integer or not, we don't really care. Okay, so the whole idea is that it's odd. It's going to be some I. Okay, so I just imagine it this way. Okay, so your I cube is going to be negative I, right? I power 9 is like I cube, correct? So you get the point, okay? So the p is actually not even important. It's just 1 or minus 1. But anyway, don't care lah. You just know it become I, right? That's your sales pitch, right? You're trying to sell people something, right? Okay. Now then this one, okay. The important thing is this one cannot be 0. Yeah, okay, because it cannot be 0, because once it's 0, you're dead. Okay. So you just to convince people that you know what? Okay. Well, since n is integer again, right? Minus 2 to the power of 2n plus 1 is not 0. In fact, this is called exponential curve, right? You better know it, right? Let exponential anything power x, you will never be 0 on what? Correct? That's why the asymptote is the x-axis, ma. Then you plus 1 is worse, right? Plus 1, you float up 1 unit, it's confirmed never even ever going to be 0. Okay? I mean, or another option you can try is to try to solve this and realize you can't solve. Okay? So either way, the whole idea is to convince people that it cannot be 0. Okay? So you just say, therefore, this nonsense cannot be 0. Ayo, sorry, let me one more time. Okay, and therefore, okay, you get this HI. Ta-da! Okay, hey, it's only 2 marks. To be honest, this is only 2 marks. Okay, now if you can get to here, you probably get a 1 mark already. All right, the explanation, as long as it's sound, as long as it's sound, it makes sense. It's just 1 mark. That's all. Okay, I'm doing it very elaborate here because I want to make sure you understand completely. All right, so you don't have to be so kiasu like me, right? Until so long for 1 mark. You might as well write essay. Okay, but you get the point. Okay, is this the only way to do it? I'm quite sure it's not lah. Okay, it's just a method, a way that you want to, whichever way you do it, you just want to be able to convince people. Okay, all right, come, let's move along. Okay, so that's our complex number. Now, by the way, we haven't talked about the kind of very common exam question. The one that says raise the power to n and then it is real. Find the first 3 smallest value of n or something like that. That one very common in exam. Okay, so that one I'll do another day lah. Not in this paper anyway. So the whole paper is not complex number paper anyway. So we're gonna have a complex number revision. Pretty obvious, right? That one no need to say, confirm when you revise, right? Okay, this is considered easy. It's an easy question, all right? 6 marks, even though it's 6 marks, but it's supposed to be quite easy, all right? One very troubling thing that I saw was that when people tried to do this, they go and use GP formula. Okay, so please take note. R squared is not AP, not GP. All right, so summation, even though sometimes related to AP and GP, right? Please do not see your summation only then straight away think of AP, GP. No, not true. Okay, this is pretty obvious. It's not AP, neither is it GP. All right, but anyway, when we see a summation, okay, a few things come to your mind straight away. All right, number 1, method of difference. Okay, number 2, AP, GP. Number 3, all right, some special funky formula. In this case, we're not dealing with those special funky formula kind of question because there's no hence part, right? Yeah, so we're not using those formula. In fact, we are trying to find one of those funky formula. That's our job. Okay, so this is not it. All right, and when you see a minus in between, very obvious it must be method difference. Okay, all right, APGP, no way, because you can sense that it's not APGP at all. All right, so the kind of things that run through your mind straight away when you see a question gives you clarity of what to try. Okay, so the first 1 mark should be rather easy, or if I like, rather painless. Okay, what I mean is this. All right, there you go. All right, a lot of people identify that it is the what is that called? Method of difference. Okay, so if you got study, you know lah. It's 2 cube minus 1 cube, and then 3 cube minus 2 cube. Okay, enough. And then the last one is n plus 1 cube minus n cube. And all together, cancel, nothing left. You're going to get n plus 1 cube minus 1. Ta-da! All right, got one friend got this wrong because you go and put 1 cube minus 0 cube. Alamak, we got this term. Okay, so be careful. All right, sometimes when you're in the heat of the moment, I want to do fast, anyhow do wrong. Anyway, this is 1 mark only. Don't be too happy. All right, then the next 5 marks comes with a lot of work. All right, pretty obvious, right? 5 marks, you don't expect 2 lines. So the next thing is, okay, I'm supposed to hence use this result to help me sort out R square. Great. Based on what I just did, I don't even see a single square. You feel it? Yeah. It's like, what the heck? I don't even see a square. Now they ask me to do a square. Now, obviously, we got to use the result that we have. So I don't know what you must be thinking in your mind, but you probably must have a sense that it has to do with this. There must be a square somewhere lurking inside, right? And it doesn't take too much to tell that this is actually just a binomial expansion. Okay? And if you expand out, there is an R square. Confirm. So how you want to do this is entirely up to you. Okay, there are a few ways that can factorize this. You can use the formula that you learned in secondary school. Difference of 2 cube a cube minus b cube. Remember that one, the vec cube formula? Okay, so cube, right? Then you have a square, ab, b square. Correct that one? So some people have problem trying to fill in the blanks because it's either plus minus, but I just don't know which one is which. So in my Sec 3 class, I taught them SOAP. Okay, very useful one, trust me. Okay, SOAP. Nowadays, you scared the virus, right? You also need SOAP. So SOAP, S stands for same. C minus, same. Same sign lah, same. Okay, the same what? Same sign. Okay, same. Or O stands for opposite. Minus is plus. AP stands for always positive. Done. So very useful. I love it. Okay. All right. Anyways, so you can factorize like that. Can you see? You actually have a difference of 2 cube there, right? So you factorize. Some people really go and expand using their binomial expansion. It's okay. Okay. Don't worry about it. Nobody will judge you if you. Some people do it like that. Okay, doesn't matter. Okay, I'm not laughing at you, but just that this looks a bit too kiddo for me. I cannot take it. All right. So you should be able to factorize this. Okay, my point. All right. So let's try to use SOAP. Okay. So I'm going to have r plus 1 minus r. Okay, pretty obvious, right? And then this one is going to be r plus 1 square, and then plus r times r plus 1, and then plus r squared. Not very hard, right? No? Okay, and of course, the first bracket here is 1, so nobody really cares about the 1. We're going to get r squared plus 2r plus 1 plus r squared plus r squared. Oh, what the heck? This is very confusing already. 3r squared plus 3r plus 1. Ta-da! So after you simplify, or whatever you want to call it, okay, expand, simplify, whatever, this deserves 1 mark. Now, the question is, you don't know what the heck you're doing, right? Because you don't know why you need to expand for what, right? Okay, so the whole idea is to be able to recognize that this is this. So you say, yeah, Mr. Ang, it's pretty obvious, like so. All right, so this. Okay, I know all the yellow parts are the same, so, okay, now pay attention. This is where you suddenly have a sum of r squared pop out. Okay, you can see that now. So based on the answer that we got in blue, right, which is on the left, okay, we understand that the sum of this rubbish is actually the sum of this same rubbish, because I just established that the yellow parts are the same. And this is m plus 1 cube minus 1. Now, this realization is mighty important. In fact, this is the most important statement. Yeah, right? Because this allows you to focus. And that's what you want. That's all. Whatever that happened after this is super easy already. Understand? Okay? Any J1 who just learned summation will be able to handle. Okay? But not everyone can sort this out. Not everyone can piece the big jigsaw puzzle together and get this equation out. All right? It's not about the mathematics all the time. It's not all about the working all the time. You can't even form the equation work what? Nothing to work. Understand? All right. So I would dare say this deserves 1 mark. Okay, and then of course from here on, I trust that you can do, but I probably have to show you how to do, right, in case you're marking and all. All right, so again, focus, right? The focus is on the sum of r squared. Can you see the r squared right there? Okay, great. All right, so law of, I won't say law, the summation, right? We do have a lot of properties, right? One of which says that I can take out constants, and that's precisely what I'm going to do. All right, I'm going to take out the 3 as well. And I can split. Remember that one? Split, yeah. So it all suddenly looks so easy, and I hope you feel the same way too. You see the R square? Great. All right, now this one is an AP, right? N over 2, A plus L. This one is just N. Okay? And I think if you identify this is 1 mark, you identify this is another 1 mark. This is probably the easiest 1 mark. Okay, but then you'll be surprised. Some people just don't know how to find the sum of a constant. Okay, anyways, then the last 1 mark go to the answer lah. It's called simplifying. Minus 1 minus 3n over 2, 1 plus n minus n. Oh dear, this looks really bad. Okay, well, because it's a show question. Sorry, how many marks do I have? I've given up now. 1, 2, 3, 4, 5. 5 already. It's a bit generous. I think the simplifying is go for. Sorry, this n no mark. This is a bit too lame to give 1 mark. Okay, sorry, my bad. Right, this process going down 1 mark. Yeah, because it's not straightforward. All right. So you want to know where you're getting. Hold on. It's a proving question now. So that's it. Hold on. I should copy and paste, right? So the journey will be a lot more present if you know where you're heading, right? So that's where I'm heading. I probably keep one eye on it and the other eye on the other side try to do it. Okay, Ken? All right. So those of you can't get the answer, you know what? I'll be quite happy if you don't just stare at the screen and falling asleep. Okay? Try to do it together with me. Come on. Try to make it a bit more interactive, Ken. Okay, otherwise it's like, okay, just watching movies, the most boring movie ever. Okay, so all right, let's do it together. Quick. All right, let's see who got careless mistake. First one to spot it. Okay, so how I will do it is I usually pay attention to this lah. Okay, so I will see that they need to have this n over 6. You see that? Okay, so which means that this 1 has to go, because there must be a common factor called n, right? So if there's no common factor called n, you're quite dead now, to be honest. All right, so you also start to see that unless you want to expand this, but I don't want, you know what I mean? It's like very troublesome. So you know what? You try to be a bit more clever so that you can, you know, there are 2 ways to do this kind of rubbish. One is to do it by brute force, expand everything, then simplify everything until 1 bit like this. Then end up go and try to factorize like this. It will work or not? Will slowly do. Okay, all right. But another way is to be a bit more cunning, which is what I'm going to train you right now. Okay, cunning in the sense that not in a bad way. Okay, cunning in the sense that keep a lookout for things that help. You see what I'm doing? I'm just rearranging. Agree? I didn't do much to be honest. I'm just rearranging the minus n, minus 1 put together, then I take out the minus. Sorry. Take out the minus. Okay, take out the minus, then n plus 1, right? Correct? Okay. And then I saw this. You see this? Okay, this is what I call common factor. So I can factorize out. And I don't have to expand that bloody cube thing that I don't like. Minus 1. Nice. See, instead of expanding a cube, I now have to just simply expand a square. Expanding a square is no big deal, right? Because you can do it with your eyes closed. Okay, because you know they're going to get n squared, 2n plus 1 minus 1, no more. And now that you see every fella got n, right? N is a common factor, you can take out the n. And guess what? You know what? I am going to squeeze out n over 6, since I know the answer is going to be n over 6. So this will give me a 6n. Agree? Okay, no, hold on. N square. Okay, now you know what? Sometimes you just have to do a bit slower. Later I do wrong, and then it'll be embarrassing. Minus half. Correct, huh? Yeah. 2 minus 1.5. Positive half. Oops. Okay, almost there already. You can sense it, right? You can sense it now. Okay, so I'm going to take out the n over 2. Yeah, not over 6, sorry, because I forgot that there's a 3 here. Okay. Otherwise, it'll be very hard to get there later. Okay, we're done. Okay, so of course you don't have to do exactly like what I did, all right? What I did was the lazy way. Okay, I won't say lazy lah. Not the brute force way. You get me? Brute force is just expand every single thing and then slowly go and one by one go and sort it out. But then if I were to do that, right, chances of it is I probably expand one number wrong. Okay, because I'm careless. Okay, so you must know what is your weakness and what is your strength. Okay, so like myself, I know I'm careless, I avoid it at all costs. So when I avoid all those steps, then I try to be a little bit more, cunning, look around, see is there anything I can exploit or not. Sometimes yes, sometimes no. Okay, so if it's no, then no choice lah. Just got to do by brute force. Any questions at this moment? Quick, right? How many marks am I supposed to give? Oh, hold on, wait, let me check. It's a 6-mark question, right? I give out 1, 2, 3, 4 already. Okay, good. All right. So like I said, the process of doing this deserves 1 mark. Right, getting the final answer 1 mark. Okay, so total 6 marks. All right. So the process of simplifying lah, getting it correct. Okay, which is at this point lah, getting it correct is already 1 mark already. Okay, but then getting the correct answer to the form, the 1 mark. Okay, so I classify this as easy. All right. Halfway there. Drink some water already. Maybe I start to talk in Chinese. Okay. Anyways, this looks scary, huh? I don't know how you feel lah. This is integration. It does look scary. For people who are terrified of integration lah, of course. In fact, not necessarily so. Anyone who allergic to trigo also find this bad. Okay, so you see the trigo there. Ooh, bad. Right. Anyway, so 6 marks. This one I would say is moderately hard. Okay, but mainly is because it looks hard, and more importantly is if you actually studied for your exams, right? It's actually okay. It's not that bad. Okay, so let me guide you through quickly, right? So they say that by considering this, what the heck do they mean by considering? Did you know what this means? It is a hint. Okay, so when they say by considering, that is a hint. They're telling you, hey, guys, look at this. Okay, this is going to help you sort out this. And they go like, oh, I don't know why, I don't know how. Okay, so do you even know how to integrate this? Now, if you think that you can't integrate this because of the n, then you are not thinking hard enough. Okay, and if you think that Mr. I just can't integrate this, that means you also haven't studied hard enough. Okay, because there is one formula that you're supposed to know. Okay, and that formula in my class we taught it in day 1 of integration techniques. Okay, and we have nickname for it somehow. It's called the inside-out formula. All right, the formula looks a bit like this. All right, if you ever have to integrate something like that, okay, it's called the inside-out formula for a reason, because the outside of the bracket, outside, is the derivative of the inside. You can see outside is the derivative of inside. Okay, then the answer is the bracket power plus 1 over the new power plus c. You want to think of this like a reverse chain rule. Okay, except that the fx can be any function. Not the secondary school version that you learn. Secondary version is very lame. That one. Okay, that one is it must be linear. Must be linear. Then you just divide by a also, right? But this one is the more advanced one, of course. That's why in A level. But the whole idea is this formula is in syllabus. You have to know, and the worst news is it's not in the formula list. Okay, so it's not in the formula list. You have to memorize. And guess what? Not only memorize. You say, Mr. Actually, I know this, but I still can't see how I do this. Also dead. Okay, so you need to not only know it, you need to know it well, and you also need to know other things like, hey, come on, how do you solve it using this? In fact, if you think about it, this thing is not hard, right? Because if you rewrite it, which I saw some people wrote it, this way. Then I know immediately that fella know exactly what he's doing. There you go. When you differentiate tangent to get secant square, right? Yeah, that's the outside, that's the inside. What? See? Answer is not hard. In fact, answer is just tangent n plus 1 over n plus 1. Done. Okay? That's the integration of it. Are we all good? And then you say, well, Mr. Ang, it's still very weird. The power n plus 1, what do I do with it? Well, turns out it's power 4. For goodness sake, tangent power 4 is 1. So no matter what power you have, 1 to the power n plus 1 is still 1, right? There you go. So it's just going to be 1 over n plus 1 minus away 0 over n plus 1. Okay, n plus 1 is constant, by the way. Don't stress yourself. Okay, so there you go. This is 1 mark. Okay, this hint is 1 mark. And you know what's the annoying thing about this hint? Is that they give you hint, but they also make you work for your hint. And this is annoying, right? Okay. Anyways, that's it. Now, then you realize that, wait a minute, this is the answer for the hint. And this is the same answer for this. Now, how does it work? How do you link it up? That's the question. That is the thing that they want you to show right now. Okay, and that's the other 2 marks that you're trying to grab. Do you understand? So this is quite independent, this question, because this one is like, oh, I solved this, that's all, right? Yeah. But now you understand that there's more to it. I need to show this statement, right? Then you go like, obviously it must be related, right? That's why it's a hint. That's why it's a hint. Number 1. Number 2 is that, hey, come on, they look exactly the same, but how great, how? Okay? So that's when you got to be daring with your trigo, actually. I would say trigo, now to be honest, it's not something to do with integration anymore. Okay, all right. So chop, you do know that you can combine them. So I'm not gonna waste space. I'm just gonna combine them straight away. Okay, so there you go. This is the left hand side. Left hand side is equal to this nonsense. Are we all good? Okay. All right. And it doesn't take a lot to see that there is common factor. All right, and the common factor is tangent nx. Then you're going to get tangent square x plus 1. Do you see that happening? Cool. All right, and you better know that your tangent square x plus 1 is what we call secant square. Even if you don't know, you anyhow guess lah. That's why it's 1 over. That's why it's the same answer as the one before. Okay, cool. All right, shown. Hey, like that, 3 marks. It's like beating around the bush, but you go round and round talking about the same thing. Agree? All right. So getting this answer, 1 mark. All right, being able to figure out this one, pretty obvious, right? 1 mark lah. Okay. So then getting the answer shown 1 mark, which is quite lame, to be honest. I think this only probably 3 marks a bit too much, right? Okay. So you see, lucky I don't set a lot of exam papers. Otherwise, I tell you, I have to do like math. I'm gonna just give you 10 marks. Okay. So I'm very stingy with my marks. Oops, sorry. That's not what I meant to do. I want to copy and paste this. Okay, hold on. Give me a while. Okay, come chop. All right, here we go. Okay, so we're done that part. Let's talk about the hence. Okay, so hence 3 more marks ago, which is talking about volume. Find the exact volume of revolution obtained when the region bounded by the okay. Now, do you have an idea how this curve look like? I have no idea. So you know what? We just go to the GC and draw. Okay, so once you draw the curve, it's not hard to tell now because x is 0 is still 0. Then you just probably look a bit like this. Okay, because x equal to power 4 is still 1, right? So it's still going to look like a normal tangent curve, the part of it that is near the origin. Okay, so not that surprising, or neither is it too obscure kind of curve. All right, so bounded by the curve, the x-axis, and this line. So we're talking about this region. So this region being rotated. So we're looking at this volume that looks something like I have no idea what I'm going to describe this with, like volcano, mountain. I don't know lah. Okay, you can imagine a loudspeaker, whatever. All right, so I want to find this volume. How to do? Okay, so first thing first, you need to then understand number 1, volume formula. Volume formula says you need to have a pi, all right, and I'm rotating about x-axis, so it must be dx, and I must make y square the subject. And of course, when this is dx, then the limits must be in x values, which is 0 and pi over 4. There you go. Okay, what is the y square? Well, y square is pretty obvious. The equation, right? So the equation is tangent square. Your job is to figure this out. But your job is to use this to figure this out. So let's say you are very clever, which I suppose most of you are very, very clever. And you can do this. You do, you get the answer. Correct. You get 0. Get it? 0, because there's no hence or otherwise. All right, nobody is testing you on your integration right now. All right, people is testing you on your observation and deduction. Get it? Okay, so don't show off your integration skills. I don't care. Well, show me you can relate to things that you already knew. That's what they want. Understand? That's why it's only 3 marks. Otherwise, this question is not easy to do, you know. Okay, but I saw students who attempt to try to solve it, you get me now? Then I so poor thing, and now we all get 0 anyway. Okay, right? So my point is you want to be mighty clear about things. Okay, so there you go. This is what I want to find. Okay, so write down here, want to find. Okay, but then how? The question is how, right? The much bigger question is you only know this, you know. Great. So you probably think, and you go like, eh? Do they look like they have some sense of similarity or resemblance or whatever you want to call it? Do you think so? Somehow, right? But I need x power, tangent power 4, no, Miss Dang. Yeah. N. How is n going to help me? Well, this is when you got to be brave. So you're going to try to say, you know what? I'm going to let n be equal to 2. Because you must understand that this is now suddenly like a formula. This formula works, you know. For whatever n is, you know, n must be positive integer, right? It's a show. Somehow, I was so clever just now, I can show this. This is a formula, you know? And maybe it's going to name after me already. Someone's theorem or whatever, right? So it works for whatever n. So if I want to use it, I probably let n equal to 2. Because when I have n equal to 2, right, I am able to figure that tangent power 4, because n plus 2, plus this, will be equal to 1 over 3. This is the magic step that you need. That's all. 1 mark. If you figure this out, the rest is domino effect. Please tell me you can solve already. Understand? Okay? Because this is the hard part. This is the part that you score the marks for. Because if you can't score this 1 mark, you can't score the rest. Okay? All right? And this is what I meant. That's it. Remember this? This is what you want to find, right? See? Agree or not? Yeah, there you go. Make this the subject. We're done. Okay? All right, we're done. So, of course, what's left to do is to get the answer. Of course, multiply the pi also. Don't forget the pi. Don't go eat the pie. All right. So, tangent square. You better tell me you know how to integrate tangent square. And if you are thinking of tangent cube, I don't know how many times I need to shake head already. Okay, so this is rubbish. Okay, tangents, you integrate trigo, you don't add power one. No such thing. Okay. So, by the way, my Sec 4 kids know how to integrate tangent square. Okay. So if you don't know, you better brush up. Okay. So tangent square is secant square minus 1. That's how we integrate tangent square. Okay, can? All right. So let this be the last time someone has to tell you this. No more. All right. For that matter, you better revise yourself how to integrate sine square, cos square as well. I mean, since you know tangent square, right? Sine square, cos square, cotangent square, cosecant square, everything you know now, all the square you can. Okay, go and think. All right. How about cube? Okay, well, you come out tangent cube, how? Die. All right. So you better know. Okay. So anyway, not enough time for today. We have too many things to teach. So we'll just make sure we focus on what we want to do. Okay. Why suddenly pi over 2? Pi over 4. Sorry, my bad. Okay. All right, there you go. This is boring already, right? This is seriously boring. Okay, and I probably will fast forward if I were watching this in video. All right, so I'm going to minus away. Great. 1 minus pi over 4. Yeah, okay. And this is going to give me pi over 4 minus 2/3. Correct, huh? It sounds like correct. Okay, so therefore, multiply by pi, which is the volume that I wanted right from the start. Remember the WTF up there? Yep. Ta-da! Correct or not? Yeah, okay, so that's the answer. Wait, yeah, okay, so that's the... Okay, so 2 more marks to give, right? Pretty obvious is the integration effort lah. So you integrated correctly, get the answer correctly. That's like total 6 marks. Are we all good, Ken? So now you look at this question one more time. Really undoable or not? Really that hard or not? Not that hard. Okay, it really just tests you on one thing. That is A level. This. That's all. You realize that this, even though this is an integration question, you don't do a lot of integration at all. Really, you just use one formula, one time. Okay. The rest, please don't tell me the tangent square is integration. Well, tangent square, that one is secondary school stuff. Okay, it's O-level stuff. Get the point? All right. So that one is not even counted as, you know, testing you. You're supposed to know. Okay. So now you look at it, you go like, hey, actually, not that bad. Okay. So let's hope this comes up for A-level, right? And then you can score full marks, where everybody will get paranoid and die. All right. Anyways, let's take a look at this one. Oh, this one badly done. Badly done because nobody knows how to do part 4. Quite sad, part 4. 2 marks only. But then a lot of people left blank. Complete blank, meaning to say they didn't even know what to try. So that's quite upsetting, right? So let's talk about this. It's going to take a while because it's quite long. All right. In fact, the whole lesson has been quite long already, right? Whew, I can't believe I'm talking non-stop. Okay, so can't be helped. Like I say, we try to do things fast. All right, the first 1 mark is supposed to be easy, but then there are people who tried, but then they cannot get it. Okay, so that means they don't know how to do. All right, and if you don't know how to do, you're quite helpless in this kind of situation. Okay, so first of all, this is called parametric equations. To find the Cartesian equation means to get rid of the parameter. The parameter in this case is called the theta. All right, and normally in those normal parametric equation questions is that if you want to get rid of the parameter, all you need to do is to make your theta the subject, and then you sub in the theta into this theta, right? And then you will have all the theta gone, then no more theta. Unfortunately, when you have something to do with trigo, you cannot do that. Simple as that, you can't. Okay? I mean, let me just show you quickly, although it doesn't make sense. Okay, let's just see from here. Tangent theta equals to 2 plus y, correct? Then what? Make theta subject. Okay, then what? Make this theta sub inside here. What the heck? You already know it looks really weird. Secant tangent inverse. What is that? Have you ever seen something like that before? No, that's the whole reason. So if you only know this method, unfortunately, you're not going to score this 1 mark, and the rest is going to be all wrong anyway because you need this answer. Okay, so this is a very mean question, to be honest. So when it comes to trigo, one thing you need to remember is that anything with trigo and it's parametric, you do not make theta the subject. You have to think of trigo formula to link them up. In this case, it's actually not hard because we all should know that tangent square theta plus 1 is secant square theta. And that's it. Okay, what do I mean that's it? You see, sorry, I don't know why I write here. Never mind. Here got some space I squeeze. Okay, so you can see that from the y equation, right? You can see that the tangent theta is 2 plus y. Okay, you can see from the x equation that your secant theta is x minus a. Correct? So tangent square is your 2 plus y square plus 1 is equal to x minus a square. Done. Okay, so if you readjust, and which you should, this is the Cartesian equation. Actually, this is also the same, right? This okay, but this is the more standard form. Okay, can anyone tell me what form am I talking about? 1 mark, by the way. Hyperbola. Okay, so this curve is a hyperbola. No joke. All right, and guess what, guys? You cannot really use your GC for any purpose right now, right? Because your A is unknown, then good luck. Okay, so you need to know that this is hyperbola, right? Which is the next 3 marks, which is to draw this hyperbola. All right, so drawing hyperbola without a GC. All right, you need to know your stuff. Okay, those of you in my class, you know already, right? How I taught you how to draw hyperbola is that the GC is a complete waste of time. Okay. Because the GC only give you the shape. What for you need the GC to tell you the shape when you can just, I mean, come on, it's either this or that. Agree? And the GC can't even tell you a lot of all the other things. Worse, you don't even have A. How are you going to key in your GC like that? Imagine A to be 1. Again, what if it's not 1? Okay, so my point is that you have a lot of headache when you don't know how to deal with your hyperbola without a GC. That means you are overly reliant on GC is bad. Okay, all right, so how to do this? So pay attention. The only thing I can think of that I would be using my GC for, okay, is this. Let me show you. Okay, I'll go to apps. Well, I should not say that the GC is completely useless. It is still kind of useful for this purpose. You see, hyperbola number 3? Yep, okay, great. This is where I want to see. You see, this is the x square minus y square version. You see that? So I'm looking at this hyperbola. Okay, that's it. That's all I use my GC for. All right, I'm looking at like this. Because hyperbola got 2 types, right? The up and down type, the sideways type. They all look like basketball to me. Okay, but anyway, you get the point? So I just need to identify which part. Okay, so that's the one, and that's what I use my GC for. Okay, so the next thing is, sorry, I should adjust it, or rather arrange it to be y plus 2. Yeah, okay, that'll be nicer. First thing first, by looking at the equation, right, you should know that the center of the hyperbola is going to be a minus 2. Okay, now that's mighty important. That's where the crisscrossing will happen. Okay, second thing is the gradient of the hyperbola. Sorry, the asymptote. Okay, the gradient of the asymptote is going to be plus minus 2 over a. Okay, all right. Hold on. Did they say sketch? Okay. Yep. Sketch. Sketch this, giving in terms of a. Okay, so we have to put it as over a. Okay. So yep, that is my gradient is minus. No, sorry. Sorry, my bad. I forgot to put in the denominator, so I can't see the denominator. Okay, so it's plus minus 1. My bad. Okay, right. So the gradient is plus minus 1 for the gradient of the oblique asymptote. Okay, in case some of you lost already, right? Because I lost you, right? Okay, let me just show you the general form. Okay, so this was what I was missing because I didn't see the denominator just now. Okay, so any hyperbola looks a bit like this. Okay, the HK and AB are very important information. All right, very important pieces of information that you want to know how to use it. So HK gives you the center of the hyperbola. AB gives you the gradient of the oblique asymptote. So the B over A plus minus. Okay, the one below the Y over the one below the X. You want to just memorize, okay? Because some of these things is like quite hard to understand why. Not impossible, but quite hard. So you can just memorize it, okay? So in our situation, can you see it's over 1 over 1, right? Yeah, so it's 1 over 1. Okay, so that's why the gradient is plus minus 1. There are 2 because crisscross. Okay, and yep, that's the AB and HK kind of purpose, right? So can we start drawing already? Can. Let's try. Okay, so let me just scroll it up a little bit. Here we go. 3 marks for drawing this, guys. Okay, so what do we know about A? A is positive, am I right? Yes. A, let's plant it here. Okay, minus 2, let's plant it here. This is where the crisscross will happen. Okay, now the gradient of the asymptote is here. Now the asymptote must pass through the center, correct? So any asymptote, you must always find the equation of the asymptote, correct? So you must find the equation of the line, the dotted line. You need a gradient, you need a point. So the point is needless to say this point. Okay, so the equation of asymptote. Sorry, I spelled something offensive. Okay, here we go. Asymptote. Right, so we're gonna have y plus 2 is equal to x minus a. So y is equal to x minus a minus 2. That's one of it. The other one is y plus 2 is equal to negative x minus a. So y is equal to minus x plus a minus 2. So you see, 2 lines, okay? 2 dotted lines. I may add. Okay, so let's add in the dotted line now. Okay, pretty obvious. This one is the one with the positive gradient, so you should label it as the one that is x minus a minus 2. In other words, you also somehow know this already, right? This is just negative of a plus 2. Okay, so who says you don't know a, you cannot draw anything? You can draw almost everything, as long as you are clear. All right, so similarly, another crisscrossing here. Must pass through the center. Okay, so there you go. All right, sorry, this center. Okay, never mind, just draw a tick. All right, so this must be the one with the negative gradient, negative x plus a minus 2, which means that this intersect is your a minus 2. Okay, now you haven't drawn the curve. You only draw out the outlines of it. Okay, so what else do I need? Well, you do need a lot of, a few more things, right? Question says, You're supposed to draw it showing the asymptotes and exact coordinate of the x-intercepts. Okay, x-intercepts and the equations of all these things. Okay. Okay. So give me a while, sorry, because there's another class going on, and there is some kind of trouble with the class. Give me a while, okay? Let me sort this out first, okay? Sorry. I need to send out the number. Okay. Sorry, because the other class got another new student, so they're not used to this. Okay, sorry, my bad. Okay, so let's come back to this one more time. All right. So we're supposed to add in all the curve already, right? So we already know that the curve looks like something like this. Agree? Okay, looks like something like this. So you need to find out the final detail. So of course, hyperbola is perfectly symmetrical. Perfectly symmetrical meaning to say this point, the center, right, is actually very important. Because if it is like this, then you jolly well know that the line of symmetry is like this. Okay, now, and in order for you to draw it nicely, you need to figure out the vertex. Agree? You need to figure out where this point is so that you can draw what, right? Okay, so how do you figure out this vertex? Now, normally we go to a GC, but even GC also can't tell you much. So what you want to do is pretty obvious. Substitute in when y is equal to -2. Okay, so you put in y equal to -2 where? Here, of course. All right. So you want to find the x, right? So you already know that they are on the same level as -2. So when y is equal to -2, x minus a square is equal to 1. Okay, so x minus a square is equal to 1. So your x minus a is going to be plus minus 1. So x is going to be a plus 1 or a minus 1. So that sets the stage for you to draw this, because this one, let me try to make it nicer a bit. Okay, here we go. So this is the a plus 1, pretty obvious, right? Then this one is going to be your a minus 1. Okay, and you're ready to draw already. Done. Okay, so there you go. That's the sketch. Nice. That's important. Okay, now of course that's not the end. You don't get 3 marks yet, because you haven't found all the x-intercepts and the y-intercept. Did they say intercepts are important? Yeah. Huh? Any x-intercept, everything you must find. So x-intercept, only y-intercept, only x-intercept. Okay, so x-intercept means you need to go and find out what is when y is equal to 0, correct? Okay, so that one is a smaller problem. I think you can solve it out yourself, right? So let me just do it here quickly. All right, y is equal to 0. You're going to get this square minus 4 is equal to 1, right? So you're going to get x minus a square is going to be equal to 5. Correct, huh? And then your x minus a will be equal to plus minus root 5. And then pretty obvious, this is going to be the one that's called a plus root 5. And this must be the one that is called a minus root 5. Okay? All right, 3 marks. Quite a lot of things to do. Come pay attention, guys. This is 1 mark. Okay, x-intercept 1 mark. The question says so, right? Okay, second thing, the shape. The shape must be correct, lah. Understand? That means to say if you draw your hyperbola like this, wrong. Okay? Hyperbola doesn't peel away from the oblique asymptote. Okay, hyperbola lean against the asymptote. All right, so the shape is important. And lastly is the asymptotes. And let me highlight this one and this one must be both correct. Then you get 1 more mark. So it's kind of stingy, but anyway, hyperbola is something you can prepare for in exam. You just have to study, you just have to practice. All right. And my advice: don't be overly reliant on your GC, because this is one type of question that your GC is not that helpful for. Okay, all right. So anyway, GC is only useful for that one purpose, actually, right? Okay, anyway, so that's part 2, 3 marks. Let's move along, shall we? Okay. Oh yeah, no space. Okay, hold on. Let me try to move this a bit lower. Great. Okay. So part 3 says, where are we now? The curve C2. Okay. So C2 is this curve. Okay. Do you know how this curve look like? The truth is this is not a difficult curve, guys. If you tell me you don't know, I'll be quite upset with you. This is a quadratic curve. Okay. So it is a quadratic curve. It is after all just a set phase curve. That's all. Right. So what it says is that this C2 intersects the C1 at 2 distinct points on the x-axis. Okay, so if you think about it, it must intersect in the x-axis and find in terms of P and Q, and hence find a sequence of transformation that leads to this and that. Okay, so let's look at the picture one more time. So this is the curve called C1, right? The hyperbola that we have. Okay. Now we have what is it called? A quadratic curve that we know is a set phase that is going to cut this curve at the x-axis at 2 distinct points. How do you think it can look like? How do you think it can look like? The truth is, it must cut here, and it must cut here. It must look like this. I mean, no other way, right? Think about it. Agree? Is what is called y equals to, hold on, what is this called? P minus x plus q squared. Now, if you look at this, and if you know your quadratic equation quite well, right? So you know that this is what we call the complete the square form. Already completed the square. So once you know that you completed the square, you actually get the turning point, right? So it's pretty obvious that this turning point, the x coordinate is called A. And straight away, okay, I think I should just do here on the screen. You should know that your Q, or if you like, minus Q is equal to A. And therefore Q is equal to A. Q is equal to minus A, sorry, my bad. Okay? So that's the Q, all right, which they want you to find, right? So Q, sorry, find the value in terms of P and Q, all right? So we found Q already, all right? Then the other one is P, correct? So if you look at P, now that's the challenge, how to find P, because we don't really know what is this turning point up here and all. So that one, you need to make use of the fact that it cuts at the roots. So the idea is, okay, one more time, the equation is here. Hold on, let me finish this. All right, so the Q is minus A, right? So there you go. Now we also know that when x is one of the roots A plus root 5, y is equal to 0. Okay, all right, y is equal to 0. So you put this in, you're going to get 0 equals to P minus away A plus root 5 minus A square. So you're going to get P minus 5 is equal to 0. So P must be equal to 5. Okay, so if you see this 1 mark, you see this another 1 mark. Are we all clear? All right, next one is the transformation part. Okay, so the transformation part quickly is a map this to C2. Okay. Because nothing to do with the hyperbola anymore, right? The nightmare hyperbola nonsense are all over. Okay, so the part 3, like I say, is just a quadratic curve. All right, study the information that's given, all right, and then you probably can figure out your P's and Q's rather quickly, all right? So like I say, these are the 2 answers. 2 more marks up for grabs. So the idea is if you have a fx that is this, and the end result is this. Okay, wait, where's P? P is 5, right? Okay. So you need to tell people P is 5, Q is A. Okay, so you need to transform this to this using a sequence of transformation. Okay, so that's what you need to do. So you're not hard, right? Okay, so first thing, x minus A gives you this. Okay, and then of course x minus A plus 5 gives you this. All right, done. Right, so you need to describe the transformation in English, right? So the first one is called is a translation. All right, parallel to x-axis by positive a units. Okay, so positive a units. Followed by another translation, parallel to y-axis this time, by positive 5 units. Okay, right. So again, the correct description, one after another, 1 mark each. So total 4 marks for this part 3 in green, all in green. Sorry, it's a bit all over the place, but I think you understand what's going on so far. Are we all clear? Okay, all right. So yeah, it's not an easy question, this one, right? But the part 4 is probably the most disappointing one, because the part 4 nobody dare to even try. Well, at least those I marked. So part 4, a lot of people just simply don't know what to do. Okay, so first of all, let's take a look at part 4. They say that a is now a value that we know, right? Okay, so the a with this. Using the answer point in part 3, which is the p and q that we have, right? Okay, so using the answer point in part 3, solve this inequality. Okay, first of all, this is suddenly an inequality question. Now, if you look at this inequality question as it is, all right, it looks scary. Do you agree it looks scary or not? I mean, how on earth am I going to solve this inequality in the first place? So it is pretty obvious, it is not a standalone inequality question. It is related to the whole question from the start until now. And you can tell rather obviously is that, hey, isn't this the quadratic curve that we were discussing up here? Yep. Well, more or less. All right, except the x is not the same, right? Because this is a mod x. Okay, so we can sense that it is more or less the same. But you see, obviously we need to use the previous answer. But the question is, now where does this come from? You get what I mean? So it is a lot of all this puzzling thing that's going on that we can't really put a finger to, like, hey, shucks, man. I know they are related, but I don't know how are they related. And if I don't know how are they related, how am I going to use the answer to help me solve this problem? That is the challenge in this question. All right, so but at least first of all, we do know the P's and the Q's, so we should write it down. All right, let me just write it down one more time. P is 5. Okay, Q is minus A, correct? So we actually have all this information. But this one, we are still clueless. Okay, we're still quite clueless about this. Like, seriously, what's going on? Now, to be honest, if you can't sense it or you can't see it, this question is quite gone, to be honest, and that's why I guess what happened to many students. All right, now you mustn't forget that this question is a part 1 all the way to part 4. Okay, and one of the biggest thing that we were doing earlier on, right, is the hyperbola. Okay, so this is the hyperbola that I'm going to copy and paste so that we can see it side by side. Sorry, I'm going to move things around. Okay, so I want you to think about it. Is there any way you think that this is related to the hyperbola that we are talking about or not? Uh-oh. All right, so that is the part that I would say is quite hard, because if you never think like that, you probably guess that this is another curve that you have to draw, which is not quite true. All right, the idea is this: if you try to make y the subject, okay, you should be able to tell that there's some similarity between them, right? See the x minus a. Right, you see the minus 1, right? You get me? Okay, so then you have this y plus 2 square root, which is going to give you a plus minus. But on the left, there's no plus minus, right? But anyway, so the idea is we're going to get minus 2. Okay, the minus we can put at the back, so it looks more similar to the form that we're looking at. So what you need to understand is, hey, wait a minute. This is the hyperbola. This is the quadratic. What are they asking for is the part whereby the hyperbola is more than the quadratic. Get the point? So you are trying to solve the inequality using graphical solution. Graphical solution in the sense that you want the part of whereby the hyperbola is more than the quadratic. Now let's go back to our diagram, which, as messy as it looks, I think it's still very useful. There you go. Where can you see that is hyperbola more than the quadratic? So you've got like A, actually, not hard to identify what. See, hyperbola more than quadratic is here. Okay, sorry, I should just color it. Can you see this part? The hyperbola is more than the quadratic above, and this part here. Can you see? Yep. All right, so some sense we are looking for something like this, okay? Except that a few things in detail that we need to talk about. Number one, this curve is the hyperbola, meaning to say if you key inside your GC, all right, using your Y plot, not the app, the Y plot, you put in the plus minus, you're going to see exactly the hyperbola that we saw. But this is not exactly the same. Meaning, most importantly, is the plus minus. Okay, so what you want to understand is that you have a plus minus because your hyperbola is like this. Okay, one more time. Okay, your hyperbola is like this. Are we all clear? Now, that's why there's a plus minus. So when you divide into two, the top half is what we call the positive root. The bottom half is the minus root. In other words, if you key inside your GC, let's say if you have nothing better to do right now, right? You go to your GC and you key in square root x minus 1 square minus 1 minus 2. You will see part of a hyperbola, but you will only see this one. The bottom half is not going to be drawn. Okay, so what you want to understand is that the negative root belongs to the bottom half, positive root belongs to the upper half, right? Again, the plus minus cut the curve into two, just like the first function question that we talked about just now, right? So the plus minus cut into two, right? Top half, bottom half, left half, right half, that kind of feel, right? Okay, so so we're talking about the top half because it's plus, all right? So in other words, if we go back to our diagram, okay, we are looking for the parts of the curve, okay, which I shall highlight now. That is this part only, all right? Because we're talking about the top half only. I want the top half to be more than the curve itself. Okay, all right. So do you understand what's going on? All right. So basically, what are we looking for? We're looking for the part of the curve that is more than, which in fact is just the x-intercept, isn't it? The answer is just the x-intercept. Okay, cool. All right. So you can sense that where the curve is more than the hyperbola is more than the quadratic equation, right? That's where the x-intercept is. All right. So that's your a plus root 5. Okay. So from the graph, let me see. What is a? Did they tell us what is a is equal to root 5? There you go. No wonder I was looking around for this answer. All right. So almost missed this. Okay. So from the diagram. Okay, hold on. I should draw a smaller version here. Okay, so here we go. All right, sorry, because the diagram is a bit all over the place. Okay, so from what we saw was this. Okay, and then the quadratic was like this. Yeah. Okay, good. All right, so let me redraw it one more time. Okay, and what we're looking for is this and this. Okay, so this is the part where we are looking for this range and this range. Okay, because we want the curve to be more, the hyperbola to be more than the quadratic. Okay, so let me write it down properly because in case you get a little bit confused by now. Okay, so we say that, well, from the diagram, okay, one more time. It's not the end now, even though it's 2 marks, but it's quite a lot of work to do. Okay, from the diagram, all right, we understand that this hyperbola more than this curve. No, don't have the mod x yet. I haven't even addressed the mod x. Okay, so the mod x is later. Okay, all right. The answer is x more than something, x less than something. Agree? And something is, I'm talking about this x-intercept, right? So if you look at the graph another time, which is up there, sorry for the scrolling up and down because it has to be done like, so it's a plus root 5, a minus root 5, right? So those are the x-intercept that we were talking about just now, right? So we're talking about a plus root 5, a minus root 5. So from the diagram, okay, we understand that to solve this inequality, this is the answer. Agree? Okay, all right, now, since a is root 5, then the answer is x is more than 2 root 5, x is less than 0. Meaning to say, just by studying the diagram that I drew out earlier on, all right, I am able to solve this inequality. Okay, because I identify that this is part of the hyperbola, this is the quadratic, and where more than is just the x-intercept, and I already got the x-intercept. All right, I just had to put in the a value and I got this. This is the answer to this inequality. Clear first. Okay, all right. Now, this is the answer to this inequality, but wait. This is not the question. Well, similar, but not the same. So pretty obvious you don't get full marks right now. Agree? You get here, you get 1 mark. Understand? But of course, you also can tell that, Mr. Ang, this and this are almost identical. You just have to do a substitution. So you're going to say, I'm going to let x be mod x. Then this equation, okay, will become this. I won't say equation, sorry. This inequality, all right, will become this inequality. Follow? Then this mod x more than this mod x less than 0 is your answer. This is not applicable because no such rubbish. Okay, so the final answer is x is more than 2 root 5, x is less than minus 2 root 5. 1 more mark. This 2 marks is seriously the most tedious 2 marks. Okay, all right, but again, it all depends on what you can figure out. Understand? What I mean by what you can figure out is like what you can see the linkage. How do they link up together? Understand? So the original question was, hey guys, solve this. That's all. They throw it at you, right? So you need to slowly figure out that, hey, how to solve this, man? Oh, wait a minute, this is the quadratic curve that I drew just now, right? But the harder thing is to actually solve that, hey, this is actually the hyperbola. Okay, but you probably just have to have the sense that, hey, it has to be the hyperbola, otherwise it's not linked at all. What? Okay, cool. All right, so there you go. And of course, once you actually figure out that one, then use the graph to help you solve the answer, but then you still need a substitution for your inequality to work. Okay, all right, so this is a rather long one. Okay, so, oh my goodness, almost 3 hours already. I tell you what, question 9, I classify it as easy. Okay, it is really quite easy. So I tell you what, in case we run out of time to go through, I'll skip this first. Okay, because it's so easy that I'll probably show you the answer keys. You probably can have a sense of it, how to do. Okay, so that one I'll probably do it last. Okay, if we still have the energy to go on. I want to take a look at 10. 10 is not easy. All right, far from it. 11 is easy. 11B is also quite easy. Okay, so 10 is actually the hardest remaining amongst the remaining questions. All right, so let's take a look at 10. Again, I'm not too sure how many of you totally left blank. Take a look quickly. Let me have a quick sip of water. All right, so from what I can recall is that many people, none actually managed to solve the part 3. Okay, so the part 3 is the problem now. All right, that a lot of people cannot solve the part 3. So let's go through quickly because this one will take a while. So it's like total how many marks? 13 marks in this. All right, the dy dx turned out to be the easiest part, and you better agree with me. All right, because that one, simply put, you just need to go and find your dy dt. Okay, so dy dt is going to be product rule. Keep this, differentiate this, plus keep the cosine, differentiate the et. All right, and then you do your dx dt. Keep this, differentiate this, plus keep this, differentiate this. Okay, and then of course this divided by that, you get a dy dx. So the problem with getting dy dx is that it is easy. Okay, so many people will be able to get to here, but not many people will be able to show. Get the idea? So if you got to here, congratulations, you get 1 mark. Okay, But there's one more thing to do, and that is how does this look like this to you? So if you're allergic to trigo, sorry, this is bad news to you. All right. How can you do this? I suppose there are a couple of ways you can do this. Yeah, a couple of ways. I believe it or not. I just don't know which one is easier for you or whatnot lah. But I'm gonna show you quickly to see if you can take it or not. All right, so I'm going to show you one method enough lah. Okay, so one of it is to divide by cosine t to the top, divide by cosine t to the bottom. Then you're going to end up with 1 minus tangent over 1 plus tangent. So then you may ask, Mr. Ang, what's the big deal about 1 plus tangent, 1 over tangent, right? So 1, this is actually tangent pi over 4 minus tangent t. And this is 1 minus tangent pi over 4 tangent t. So if you can recall your addition formula for tangent, this is tangent pi over 4 minus t. Ta-da! So I guess that some people, when they did this, they actually work backwards. Okay, they go expand, then they try to work backwards, which is okay lah. Nobody will know anyway. All right. So this is one trick, one way you can do it. The other one is to use your addition formula for sine and cosine. Okay, so you use sine cosine, then you use change the cosine to sine, whatever lah. Okay, so it's just trigo. All right, so don't waste too much time on that one. By the way, it's just 2 marks. Okay, so if you got a dy dx correct, 1 mark. You get this correct, 1 more mark. Okay, all right, let's move on to the sketch. Okay, now the sketch is interesting. Yes, this one I probably need to talk a bit more. Okay, so it's a parametric curve. So of course we go to our GC. Okay, so like oh sorry, we should get out of this. Okay, so you go to mode, right, and you go to parametric mode. Okay, and then you're going to go to your graph and you're going to punch in the equation, which I already did. Okay, so one thing I want to nag, and from the workings I marked, right, there are still people who never remember this. All right, I nag like mad already. You also don't remember. Every time you plot in your parametric curve, okay, you're very excited to see the curve. I know, but please don't graph it. Okay, don't graph it immediately. First thing you should do is go to window. Okay, because the window by default is always 0 to 2 pi. Okay, so pay attention to the question. Your question is 0 to pi over 2. So you make sure that you really key in the 0 to pi over 2. Otherwise, your curve will look different. All right, what do I mean? Well, you see, if I put in pi over 2, I think this is pi over 2. Okay, then you're supposed to see. Sorry, why nothing comes out? You're supposed to see. Nothing. Wait, hold on. Okay. And my GC hang. Does GC have the same problem? All right, hold on. Let me double confirm. 0 to pi over 2. Something is not right about my GC. Okay, so hold on. Zoom 6. I don't see anything. What's going on? I'm in radian mode. What? Correct? Okay. Anyways, my point is you remember to change your window. Okay. All right. Pi over 2. Take note of that one. Because a lot of times people forget about this, and then when you draw, it may look different. All right, and in this case, it does look different. All right, so if you draw from 0 pi over 2, let me try again. Somehow my GC is not working. I don't know why. See, seriously. I close it first and reload it later. Okay, but what I'm trying to say is this. All right, if you use the correct domain for your t, all right, your curve is going to look like this. If you didn't bother about your window, all right, meaning to say you have 0 to 2 pi, your curve is going to look like this. This is wrong, outright. Okay, outright wrong, right? Because and worse is it may just affect your further answer later. All right, further answer later because you're going to have a wrong impression for the area and so on and so forth. Get the point? So you want to be very careful on that. Okay, so that one I can't nag enough. All right, if you go to parametric mode, the first thing you do, you always check your window. Okay, and the worst thing is every time you zoom out, right, it goes back to 0 to pi. Okay, so that's I don't think it's a bug, but just you see, it's always I set it to this, right? But even if I zoom out, I zoom 6, okay, it'll go back to 0 to pi. Okay, so somehow it is like that. All right. I'm just not very sure why my GC suddenly decided not to work on me. Hold on. Is it? Oh, maybe I didn't press enter. So smart, right? Okay. So 0 to 2 pi, it's going to look like it's still nothing. Okay. I sorry. I'm not too sure what's going on with my GC today. Something is just not working out. Oh, correct, oh? Everything correct, what? Shucks. Okay, this sucks. Okay, so anyways, like I said, you should, all right, be able to get something like this. Now, a few things I want to nag, right, and a few things that I observe from what I mark, right, is that, again, whether you include or don't include, you must be very clear. All right, in this case, all right, you're going to include 0, you're going to include pi over 2. Now, what you are supposed to do, okay, what you should do, right, is when you are in the GC anyway, right, you go to second function calculate and you put in the value. Okay, you go and put in the value, 0, all right, and it will give you the coordinates that it turns out. But I don't know what's wrong with my GC today. I'm very sorry for this GC dysfunctional thing. Okay, so I have no idea. It works normally. Decided not to work today. Correct, huh? I just saw it. Anyway, never mind. All right, so my point is you sub in t equal to 0. Okay, it's not hard to tell, right? When you sub in t equal to 0, you're going to get x equal to 0. So you're going to get this point called 1. Okay, and you're going to substitute in t equal to pi over 2. Right, so t equal to pi over 2, y will be equal to 0 because cosine pi over 2 is 0. Okay, then you're going to get e pi over 2. So that's your x-intercept. So the x-intercept is very important, and this is inclusive because your t is going to be equal to this, and it's going to equal to this. Okay, so like I said before earlier on, at your level, please don't do this. Please don't do this. Okay, this is not O level. Understand? All right, you better make sure you are certain whether you want to include that point or you don't want to include that point. Don't leave it dangling there. Nobody cares. I mean, nobody knows what you are thinking. Okay. Question says you need to find the turning point. Please don't use GC. All right, because GC cannot help you with exact. Okay, so you need to do the exact thing yourself. All right, and the truth is it's actually not hard. Okay, the truth is actually not hard. So the sketch is supposed to look like this. All right. The x-intercept, y-intercept, you can get it rather quickly by putting in the extreme values of your parameters. The turning point, right, since you already have a dy dx, okay, you just have to let your dy dx equal to 0. And it's a very fast working, really, because there's a whole reason why they want you to show this. Tangent this equal to 0, and if you're only caring about the first quadrant answer, it's pretty obvious that it's pi over 4. Okay, so all you need to do is you don't even bother going back to GC, okay? All right, just put in pi over 4 here yourself. Okay, because if you put in the side GC, GC is going to give you a decimal number, which is not helpful. So you're going to get e to the power of pi over 4, and then 1 over root 2, and then e to the power of pi over 4, and then 1 over root 2. All right, they happen to be the same coordinates, so that's the turning point. Okay, so this first part is 5 marks for the sketch and the differentiation. So the differentiation alone take up 2 marks. You see the 2 red ticks there, right? Okay, now the diagram itself is 3 marks. Okay, the shape, meaning to say no extra parts, no extra parts. Extra parts, you don't get 1 mark already. Okay, all right. This one must be correct, and the shape itself, 1 mark. Okay, so total 5 marks. It's not that hard. Okay, so make sure you are able to get the 5 marks. Okay, let's move along. Find the equation of the tangent to the point where t equals to pi over 2. Now, this one is a giveaway. Okay, it's a dead giveaway. So I don't know how people can actually get this wrong. Equation of tangent only, right? So if you want to find equation of tangent, what do you need? You need a point, you need a gradient. And that's it. Agree? So at t equals to pi over 2, go and solve the point, right? So the point is not even difficult because tangent sine pi over 2 is 1. So it's e pi over 2. That's x, sorry. Y will be cosine pi over 2 happen to be 0. Okay, so y will be 0. Okay, so it's supposed to be, I mean, it's supposed to be quite straightforward, right? Okay, next you need a dy dx. So the dy dx will be tangent pi over 2, right? So tangent pi over 4 minus pi over 2, that's like minus pi over 4. That's going to give you minus 1. And we can use calculator. So the equation of the what's it called? Tangent is a dead giveaway. Okay, but believe me, giveaway still got people get wrong. Okay, but that one I attribute to carelessness. Okay, really just plain carelessness. So the distribution of marks, if you get the answer, 1 mark, pretty obvious. And if you got all this information correct, also 1 mark. Okay, so I mean, if you get the information correct, you can still get the equation wrong. That's just you. Okay, all right. Then we move on to the most exciting one. This one. Okay, so this parametric equation question turns out not that bad, except the last part. Unfortunately, the last part is the part where I didn't see anyone get it right at all. That means all together, everything. Okay, so it's a 6 marks question. You don't expect 2 steps and get it done, right? So you probably have to think things through a bit. Show that the area bounded by the region R, sorry, the axis and the curve is this. Okay, now we already have some sense of how the curve look like this lah. Okay, so where's the region R, you think? Here lor. Okay, but actually it doesn't matter, right? Okay, but I mean it does help if you know where you are, what you're dealing with, isn't it? Okay, so at least you know, I know the limits, you know, I know all those stuff and all this. So okay, that's the area. Okay, let's think about the area. We learned this in secondary school. Okay, if I want to find area, I need to integrate. I'm going to do it with respect to x. I need to make y the subject. Okay, and when that happens, I'm talking about the x limit. Let me just do a quick sketch here, so I don't have to keep on doing this scroll up and down rubbish. Okay, here we go. All right. Okay, so it has to be e to the power pi over 2, right? So this will be e to the power pi over 2. This will be 0. Sort out this joker, you get the area. But the question is telling you that this area is this. So you're supposed to make this look like this. It's not as straightforward as just solve it. I mean, if you ask me to solve it, I'd probably find it a little bit easier because it's like more straightforward. I know exactly what to do. But now you're asking me to show or make this look like this. Oh, okay, now that's a bit scary. But chill, okay, because after all, this is what we call parametric integration, right? So we understand that y is just this. So integrating this is the same as integrating et cos t. But you cannot integrate something in t with respect to x. It doesn't make sense. So you got to change your x away as well. So what do you mean by change x away? This is called integration by substitution. Okay, so you got to substitute away the dx. How do you substitute away the dx? Well, you've got to come all the way to here. All right. So that's your dx dt. Let me just again copy and paste so I don't copy the wrong thing. All right, here we go. All right, so I'm going to paste it here. Good. So you can see it side by side rather than I scroll up and down, right? Then later you'll vomit or seasick or what. Okay, so you can say, hold on, okay, good. You can see that your dx, if you try to make dx a subject, it's going to look like this, right? Et cos t plus et sine t dt. Oh, great. Okay, now wait a minute. When this is dx, these are what we call x values. There, 0, x values, e to the power of pi over 2 x values. But now it's in t, you cannot keep it that way anymore. So you better remember where did I get this? How did I get this just now? I use my GC, right? I put in t equals 0. How did I get this? I put in t equals to pi over 2. So you got to change the limit as well. There you go, guys. This is what you're supposed to try to make it look like this. And some of you who are a little bit more advanced with your trigo, that means to say you are quite good with your trigo and all, right? Then you go like, hey, I see my double angle. I see a double angle. Yep, you should be able to see a double angle, okay? But it's not so straightforward actually. So you do want to be a little bit of a careful here, okay? So you see there's an et everywhere, right? So I'm going to factorize out the et. So it's going to be e2t, okay? Then I'm going to have cosine square t plus sine t, sine t cos t, okay? All right, you probably have a sense of it, okay? Cool. Then that's where you can have a sense that the double angle formula will arrive somewhere here. Good news, bad news. Good news is yeah, that's correct, but bad news is you still have a lot of other things to do. So you know what's the strangest thing when I saw this question? This. Okay, that's at the back of my head I was like wondering, what is this minus half going to drop from, you know, like seriously? Okay, so it turns out you'll work out very nicely, but you just got to keep your nerve, right? You just got to keep your cool, really. Okay, so what I'm going to do is I'm going to split it up into 2 parts to do. All right, so I'm going to have a half, and therefore I have my 2 sine 2t. Now, notice you already have part of the answer. Okay? But somehow we need to have the minus half. Number one. Number two, you need to get rid of this. And it's like, great. Are you convinced that this is actually this? Not easy to convince, but you just have to have the courage and the sense that, hey, I think I'm doing the right thing. Okay? Now, pay attention. This is, after all, a value. Now, if you are that confident, you probably tell yourself that, hey, this is maybe that minus half. And I just have to work on it. And you're right. Okay? But then you go like, this half, how? Something is wrong already. Well, the trick to do this is to really just work on this. Okay? So let me show you how I work on this. You better know this is called by parts. There's only one way out, right? It's called by parts. So this is exponential, this is trigo. So we're going to keep the trigo, integrate the exponential, right? You better know. So I'm going to keep the trigo, integrate the exponential, and then I want to minus away. Okay, hold on. Okay, minus away this thing, and then I'm going to differentiate. Correct. All right, you got to differentiate the and yeah, that's, it looks like a big mess lah. By the way, that's got limits in it lah. Okay, so you better jolly well know that, hey, there's limits one. Okay, then the orange part, let me just continue writing in orange so it's not so confusing. So the green part is what we call the by parts. All right, and what you need to know next is that this nonsense is solvable. Solvable in the sense that it is a number that you can work it out. Okay, so you can work it out, and it's not hard because when you put in pi over 2, cosine pi over 2 is 0. There's a godsend, really. Okay, and you're going to minus away 0. Cosine 0 is 1, by the way. So then this is just half. Don't you need a minus half? That's where the minus half. Okay, now not only that, you also start to see things working out quite nicely in the sense that, hold on, this minus and this minus turn out to become plus. And then you take out the half, you are going to be pretty surprised. You're going to see another double angle formula. So that's not the orange part. Don't mess up with the orange part, okay? So we have a half. Hey, how come my orange part looks so clean? Yeah, hold on. There must be... Oh dear, I missed out the E2T. My bad. Okay, sorry. This is a careless in the presentation. Oops. Okay, so when I split, I'm supposed to have it there, right? Yeah, sorry. It was from here. Okay, so I missed it out earlier on. Okay, so the E2T must be there. There you go. See, half plus half give you 1 whole. Agree or not? So it's 1 whole chunk of this joker minus half. That was how we started, and this is how we ended. So we say shown. Okay, all right, come, let's talk about the marks. All right, 6 marks, but it's not for these, because there are more things going on at the back. Okay, so we're not quite out of the woods for 6 marks. Okay, so if you ask me, I would say that the substitution correct is 1 mark. Okay, so you better know how to substitute away the y and the dx and all this. Okay, so put everything in terms of t. Okay, and then of course the by parts, which means the green color part, okay, must be correct. And eventually the process of coming down to show must be correct. So only 3 marks. Okay, why only 3 marks? Because there are 3 more marks going along. Okay, so that's all for this one, showing the area. All right, then the next one of course comes from this one, evaluate this. All right, that means they really want you to solve this now. All right, now this is an integration question already. Okay, you can think of it as nothing to do with the question, nothing to do with the graph. Okay, so integrate pi over 2 0 e2t sine 2t dt. So just solve this. That's all. 2 marks. Okay, 2 marks for doing this by parts. It's not difficult. All right, we have a taste of it just now. So we're gonna keep the trigo, integrate this. Okay, minus away the integrate of this, and then differentiate this. Sorry, t. Okay, and this is 0 pi over 2. Oops, This is pi over 2 to 0. Okay, just work this out, really. Just work this out, not difficult. Now, you know what's the best thing about this? When you put in pi over 2, sine pi is 0. Nice. When you put in 0, sine 0 is 0 as well. Nice. Okay, so everything is quite nice about this. And then we're going to get this, which you better have a sense that, wait a minute, I have another by parts to do. And that's right. So this kind of question is the kind that you better know. You have to bring it to the left later, that kind. Okay, so there's a 0, right? Put a super big bracket, please, because there's a second round of by parts. So I'm going to keep this, integrate this, minus away the integration of this, differentiate this. Okay, here we go. All right, so the limits, put it in. This one, pi over 2, 0, something like this. Are we all good? Then you better realize that, again, this is a number that you can work on. All right, it's not hard to work it out. Cosine pi, all right, you put inside, you're going to get cosine pi. Cosine pi happen to be minus 1. Okay, and then you're going to get e pi over 2. Okay, minus away cosine 0 is 1, so you're going to get half. Okay, and then this one minus minus become plus of this. Okay, all right, good. Then of course, important thing is to realize that, oh my goodness, so ugly. Okay, but my point is to shade this and to shade this to make a point. All right, can you see that they're the same? Cool. All right, so you better know that they're the same. Obviously, this is actually a minus, not a plus, because of the bracket outside, right? So it's a minus, you bring across, it becomes plus, so it's 2 times on the left. All right, and over here, everything becomes positive. Plus. Agree? Okay, good. Divide by 2, we solve it. Ta-da! Okay, like that, 2 marks only, poor thing. Okay, so that is the part that they are asking us to evaluate. This one. Okay, evaluate only. Okay, done. That's the evaluation. Done. Then they say, hence, find the area of the shaded part. Okay, so we already knew that the area, now I'm running out of colors. Can you believe it? I do so many colors until right now. Okay, the area that we're supposed to find was actually given by this formula that we so-called show in the previous part, right? Minus half or something like that. Remember this one that we try and do here? So this is the area, right? Okay, so that's the area, and pretty obvious is I just solved this. Okay, so therefore the area will be e pi over 4 plus this minus this, which is going to give you e pi over 4 minus 1 over 4. Okay, all right. Total how many marks again? 3 marks for this part, all right, because 3 marks given earlier on already, right? So this one, getting the answer, obviously 1 mark. Doing the by parts correctly, 1 mark. Poor thing. Okay, getting the answer correct, 1 mark. So 1, 2, 3, 4, 5, 6. 6 marks. This 6 marks not easy. Okay, like I said, I didn't see a lot of people getting these 6 marks in full. All right, quite hard. Okay, but you can't say that because it's hard, oh man, it won't come out for A level. Not true. It's just by parts after all. Okay, but definitely because yeah, together it does look a bit harder. Okay. All right. So I hope you're still with me, not like dying off already. Because I just checked the clock. It was like 3.5 hours. Can you believe it? Okay, so like I expected, I don't expect to finish the whole paper in 3 hours, really. Okay, plus going through and all. So it does seem like we have leftovers. Okay, so we have question 11, question 12, no, question 11 A and B, and question 9. Okay, question 9 is the easy one. So this one is actually secondary school kid also can do one. Okay, so 9 I'm not very keen to spend time. 11 and 12, yes, maybe you need to spend some time because after all this is a small angle approximation versus another vectors question. So but I think we'll stop here. All right, it's very long already. I think we'll go on also. We probably cannot fully absorb most of the things. So what to do with these questions? If you are marking on your own, you can email me. Let me know if you need the marking scheme I sent to you. But for those of you in class, right, we can spend some time to go through during class time. Okay, so during class time, that means over the weekend or whatever lah. Then we go through the question 9, 8, and sorry 9 and 11. Okay, during class time. Okay, so the rest we are more or less done. All right, so important ones, hard ones, you know which one already. Okay, so I hope you learned something useful. Okay, so before that, okay, now next question I have is anyone got any questions? Because it's a very strange problem today that I can't hear you. So you can type now. Any questions? Quick. No questions? So all of you are very clear about what is actually happening. I mean, it's a long day, you know, really long day. It's a super long 3.5 hours. I'm talking non-stop. I'm the one talking non-stop, you know, not you. Okay, so okay, I probably sore throat tomorrow already. Then cannot go see doctor. People thought I COVID-19. All right. So anyways, if you have no questions, fine. Right. To our guests, thank you for joining us. Okay. For my students, you got a question, you can still ask me, right? Because you're still going to see me. Okay. So left with that last two questions, going through that one, we leave it during class time as you like, you know, no chance to go through every single thing. Okay. Can? All right. So no questions at all. Then we're just going to end it today lah. Okay. I hope that's helpful. You know, because you all probably didn't know until you take the exam, right? And I was quite so-called upset when I marked some of your work because, you know, it seems like you haven't studied for the exam. It means I all get 30 plus, that kind of marks. Okay, so which is also a reflection of what you may get, if you are actually having a ME exam. So it's not a bad thing that we actually try to simulate it on our own, right? Then we wake up on our own first. Okay, so anyway, I'm like talking to myself because I can't hear you. So I'm gonna end it today. If you have a question, just contact me. Okay, and then we try to sort it out. Okay, but other than that, I'll see you over the weekend. Okay, so over the weekend we'll be doing sampling. Continue, yeah. Okay, so that's all the time we have for today. Okay, any questions? Don't have, then we say bye-bye. Okay, I can't hear you. Okay, so bye-bye guys. Bye-bye. Bye. I'm gonna end the meeting. Bye.